Oh, what up? We got 610 in the chat. Let's go. Fusion as well. Let's go. Big news, big news. Uh-huh. Okay. Oh. Oh. Okay. Let's see here. I'm in the middle of just real quick. I remember there's one part that I need to make for my printer enclosure based on the new parts that I have. So that's what I'm doing here. Gotta make a midplane. What's up, the Techno Mister? Right now, in this exact moment, I'm making a midplane so that I can mirror this body, this one, over here. And the reason why I'm doing that is because this originally rests on top of what rests on top of this part is originally a 1/8 inch plate of acrylic, but now it's a 1/4 inch plate of acrylic, and I need the height of the top of that plate to be the same, which means that this thing is going to have to be lowered down with respect to these mounting holes that go on the side here. That is the deal. 0.125 inches downward. Okay. And now what I do is take this and this. I try to do my CAD operations like as efficiently as possible. I'm like, oh, like what's the least number of clicks it will take me to accomplish this thing? You know, I'm constantly thinking about that. And so I'm cutting through this, but I don't want to cut through this or this, just that. And then this is a separate body, which I can disregard. Separate body, can disregard. And now we have something that will fit better. And I'm just going to call that fine. I'm not going to worry about the potential bad looksmanship of these weird corners and stuff. I'm just going to call it good, and we're going to print it. These other bodies here can go away. A little bit of open sourcing for the blowing fans. I believe Bispy 3D model is the X carriage that attaches to my Anycubic. Interesting. What's up, AZ3D? How is it going? We got everybody here on a Saturday. What's up? I love that. This coffee kind of tastes like ass. That's okay. I need it to survive. I made it, so I have nobody to blame but myself. Okay, this is the light fixture. And we got to open up Prusa Slicer. So, fun tip. I don't know, the 3D printing purists will hate me for this, but sorry I don't have $1 billion to spend on nozzles. I have a 0.4 millimeter nozzle attached to my 3D printer, but I realized at some point during my my graduate schooling that you don't have to have a line width that's exactly the same as your nozzle diameter, because you can just always force way more material through the nozzle, and it probably is not as good quality or whatever, but that's not what I need. It's just much faster. So 0.4 millimeter nozzle, I never change it out, but sometimes I modulate the line width and the layer height to match a profile that would typically be for a 0.6 millimeter nozzle. And that can cut my printing times like in half. You're basically just like, you know, pretending you have a bigger nozzle and you get less detail, but who cares about detail when you're an engineer building big stuff, you know? So that's that, and this is going to be a bridge. I'm just going to, should I hope that the bridge is okay? The problem is that the 3D printing um, stuff, oh, that kind of sucks. Maybe I should print this upways. Yeah, I'm going to do that. Sue me. It's going to be strong enough. Let's see here. Actually, this hole is too small. I forgot about that. Because I need this. I forgot that I added that in later. But, oh, I think they tap this to be M5. And you know what? I can do that. I can do that because this is, like, how big is this really? Should be 3.8. So they're essentially expecting this to be tapped with an M5. Tapped with an M5 is kind of crazy. I'm going to go for, what do I typically tap M5? I'll tap a 4.4 with an M5. I won't tap a 4 with an M5. That seems like a headache for no reason. And I'm going to make it go all the way through because I don't like to worry about blind holes when I'm tapping. I just want to tap as far as I can go. I hate like being like, oh, am I at the bottom? Am I at the bottom? And like potentially ruining all of my work. So this looks like it works just fine. These are supports, aren't they? That doesn't actually belong there. Those are supports that are designed to be breakaway, these 4 things here. I forgot about that. So good question. Should I get rid of those? I'll trust the original designer of this file. Yo, Techno Mister coming in with the data. I tested various line widths with a 0.4 millimeter nozzle. The widest you printed was 1.5 millimeters. That's crazy. So this reminds me a lot of, I mean, really, they're all circles, right? There is some strange fluid mechanics that can occur when you have a really small nozzle. Some unintended stresses, especially with high viscosity fluid like molten plastic. That can kind of make it lower quality. I think that's probably what they're worried about. Otherwise, the only thing that you need to worry about when using a small nozzle to print at high flow rates is the resistance, right? Can it actually force that much material through? And that typically is not an issue. It reminds me a lot. One of my friends in grad school was working on this project because we were both doing additive manufacturing research. And so one of his things that he was making, and I think he's still working on it because he hasn't graduated yet, is a like a nozzle that can change shape, change diameter, but specifically for not for FDM, for FDM molten plastic, thermoplastic printing, but for something else, which is called direct ink writing, which is very similar to the material extrusion printers, FDM. And the only difference being the only difference being that it's with a elastomer, or like, so elastomers typically, like really high elasticity materials, are not meltable typically. And so instead they're cured, silicone or polyurethane, that sort of thing. Um, oh, filament thermal transfer. Yeah. That's a good one too, for sure. That's the other thing to consider. But yeah, so for direct ink writing, like we were using silicone, high viscosity silicones, and so we were on this research track for silicone printing, really high viscosity material, like 100, like 10 to 100,000 poise, which is like 10 times higher than water. What am I talking about here? I need to refresh myself on viscosity um, uh, examples, because I need to make sure I'm not spewing nonsense. Viscosity table. And the engineering toolbox, my goat. Okay, so centipoise is the um, centipoise is the is that the SI unit? Is that the SI unit? SI unit for viscosity, because I know it's a little bit weird. I was just working on SI unit is Pascal second. Pascal second is equal to 10 poise or 1,000 centipoise. Okay, great. Okay, so Pascal second is the base unit, but centipoise is basically based around water. So like water will have a viscosity of around like 1 centipoise. You can see here a lot of the chemicals, like base chemicals, acetic acid. Wow, acetone's viscosity is low as hell. That's crazy. But like alcohol, methyl alcohol, really low though. Propyl alcohol, a little bit higher. Interesting. Then you got like oil going up to like 33. This does not give as many ones as I would have hoped. What's the highest one on here? It's not even that high. Ellsworth adhesives will have a good one. Okay, so water, 1 to 5 centipoise. Blood, 10. And then we're going up to honey, 2,000, 3,000. I remember hearing like 1,000, but 2,000, 3,000. Cool. Then, so we were dealing with like 10 to 25,000. We had two materials that would be mixed together. One was less, more like chocolate syrup, like 10,000. And the other one was more like peanut butter, like 100,000. And so those would be mixed together through a static mixer, and then we would print with it. And there were a lot of things to deal with. I dealt more with the control side of like controlling this high viscosity fluid deposition, so that you get rid of the parasitic effects of like stringing and that sort of thing. And he was working a lot on the hardware stuff. But then I transitioned to robotic manipulation 2 years into grad school, and so I had a crazy wild ride. All right, we are printing this. Sorry about that tangent. We are printing this, and we are printing it because we are not going to use supports, but I do want to use, what's it called? Gyroid infill, my goat. Big and strong. Okay, I believe in this. I believe in this design. Let's get that going. Got a couple more things to do with this printer. And I also realized that I didn't have a like the right length of fasteners, so I had to buy those. So those should be coming soon. But printer enclosure almost done, but it's got to be done because I've got videos to make. Let's see here. Cool, man. Yes, so that's that. I'm not worried about that anymore. Now we're back on Web3. So if you weren't here last night, last night I was hanging out with some friends, which is rare for me nowadays, so that was fun. But I was working on this ratchet and pawl mechanism for latching the, um, you know, the web. And so we've got one latch surrounding this hinge and one latch surrounding this sliding mechanism. And so this is very well thought out. I have some confidence in this for sure. There were a couple things that I missed that somebody pointed out at the end of the last stream, and I was very thankful for that. But this is gonna have to be printed in SLA because it's pretty high quality, and I hope that even works. That's like this morning I woke up and was like, maybe it's still too much for SLA, too little for SLA, but we'll see. I think it should be okay. But yeah, somebody pointed out that I don't have end stops for my dovetail linear guides. So basically what that means is, you know, this part, this part, this part, this part, this part. All of these are supposed to slide along these dovetail linear guides here. However, we don't have end stops, so they can slide forever. So we need to make sure this goes up to 10 to 5. 5 up is the maximum. And so we need some kind of end stop there. Start with that. And I'm thinking that we want the upper end stop on one side of this and the lower end stop on the other side of this. That's what I'm thinking. So let's see. So if we were to do the upper end stop here, that would mean that maybe that means we can. Is that crazy? Can we squeeze out a little bit more material storage? Is that stupid? That's kind of dumb, right? I mean, what's 1 cubic centimeter gonna get? 1 milliliter? What's that gonna do? I don't know. But I'm thinking we have one over here. Question is that we don't want it to just be like completely like unengaged, you know, from the dovetail if it goes too low. So we kind of do want to keep it small. Let's give it a thickness of 3 millimeters. I don't know if that's going to be part of the aluminum or part of the plastic, but in any case, it's going to be an end stop. It doesn't have to be like crazy strong. So this and this need to be parallel. But alternatively, if I'm thinking about the way that I'm assembling this, but I really don't want to eat into this, that's the thing. If I'm thinking about the way that I'm assembling this, this is going to have to mount on that aluminum somehow. I mean, it could be part of the aluminum, but then how do I put this? Okay. So these two things here, this part and this part, are now separate parts because there's this latching mechanism assembly that I've placed in the middle. And what that means is we can keep the end stops being rigidly attached because this one can come in from the bottom, meaning it doesn't have a bottom end stop. This one can come in from the top, meaning it doesn't have a top end stop, but this one's going to have the bottom end stop. So you slide them in like this, and then you fasten them through, and now they're one part. I think, yes, that's perfect. Okay. So what this means, okay, I do want to see. I think if we take this new body, and if we go over here, we project that shape, we offset it by 0.1, 0.2, 0.2 and 0.1, because we need both. 0.1 for the stop and 0.2 for the sliding surface. Then we continue the sliding surface line all the way up here, so we can cut that out. Boom, 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 boom. Okay. And yeah, sure. Because yeah. Yes. Just like this. That is now an end stop. Rigidly built in. Okay. So end stop there. Incredible. Then we got to take this stuff and move it down 15. This is for the minimum wrist. The minimum wrist. And we can't have the end stop be over here still, because this needs to slide in that way. We have to have it be over here. I can't really see a whole lot. So why don't I do a section analysis? Okay, section analysis to here. Okay, so we need the lower end stop here. So to stop this from going further down, I think we do kind of the same thing, right? I think so, at the very least. Gotta make sure this is what our shape looks like. Okay. So I'm thinking, stop this from going down more. Same thing where this goes 5 millimeters out. Maybe we don't even need that much. Can make this one be a little bit chiller of an end stop. Because who got a wrist that small anyway, right? Let's maybe go 2.5. project this. Looks like we are still on the profile. Are you hearing the children outside? Is that what you're hearing right now? Is that why you said children? I have my window open. Sue me. It's a beautiful summer day. It's one of my last weeks living in the city, so. Okay, I'm gonna have that go there. And symmetrical question mark? Yeah, that works. With a new body. Then instead of the old ways that we did it before, I'm going to cut this body with that body, keep the tools. Okay, and then this and this become one and the same. And this is the lower end stop, meaning it must go higher. And that means we just take this and zoop. And then on the sliding surface, like we did before, 0.2 clearance. And whose wrist is that small? Yeah, that's crazy. You're right. I'm sorry, there's a delay. I was like, that's crazy. You can hear the kids outside. Great. That's it. That's the shit. Holy cannoli. Okay, so those are the end stops. We need some fasteners and some springs. So let's take a look here. Okay, let's see here. Make this go back up to the neutral position. Okay, so this button that oh, this is still in the wrong place. I was like, this looks like an interference, but I just forgot to move it back. There we go. Okay. So this button up here, that's the release button. So imagine it. You like click, put this on. It's like way open. You just slap it on your wrist, and you just like, and it like tightens on. You let go. Great. It's on my wrist, and you press the button. It's off your wrist. Super easy. Super easy. Barely an inconvenience. Wingstop. Wingstop sounds good. I do have some weird happenings here with the dovetail, which I can probably fix See that? I'm gonna make a little thingy. Although, you know what, I should like just take a look at this honestly. This part here, right? Because we got fasteners to deal with. So I'm gonna take this part and cut it like that. Yeah. That means we get rid of this and this. Whoa. I cut this with the wrong thing. Okay, we gotta take this part, cut it with that. Boom. Boom. Okay. Then take this part, cut it with this if we can. Oh, killer. Nice. Okay. Now maybe that wasn't the right way to do that. I probably should have just done this. Back to the Future self-lacing shoes. Nice. 610's got the whole setup here. All right. Okay, so there's this and this. I feel like some fillets are probably needed. What is that? Some fillet. I'll probably just do a fillet right here, I guess. Two millimeter. That doesn't interfere. Could even do 3. Yeah, let's go with that. What's going on up here? Fillet here, fillet here, 3. Interesting. Huh. But I could do this or not. This and that. Okay. Sure. Why not? I mean, fine. Looks good, I guess. I'll fill it here then. Okay. Okay, so this part, kind of wacky. Kind of thinking. Instead of trying to accommodate something like this, I should just, I'm just gonna like do the cringe thing and have people ignore that I'm not good at engineering. 2 distances here. So we need, I want distance and angles. We can make this look really professional. Should be 30 degrees because I use 60. .30 should be straight, and that does look straight indeed. 30 degrees and 0.6. Great. And over here, we'll do the same. 0.6. 30. Okay, negative 30. There. I'm sorry? You can't do it? You good, bro? Wait a minute. Flip. There we go. 30. There we go. 0.6 and 30. Okay. Good. Now no one will ever know that I don't know what I'm doing. Yeah, let's go. Let's get a fusion party going. The CAD software? Oh, no, no, no. We don't want to open up X. Get out of here. This is SolidWorks. This is Autodesk Fusion 360. Joining pieces of a V6 hot end together since it's all screwy. It's definitely screwy. You got that right. There do be screws. Okay. So we got a little thingy going on. How do we do this? That's the question. Wait, my question is, just want to make sure real quick. Okay, we're still engaged with this linear slide here, so that's good. We're not like off the track. I don't want to be off the track. Never be off the track. Never ever. So we got to fasten these together. Is that where we're at? Is that all I have to do left? Think. This is like if we look at these, like this part's good. It's everything we need on there. This part's everything we need on there. And we just need to fasten these together. So how do we do that? How do we do that? What kind of screw might we deal with? Okay, so this is 40. So I have a 40 millimeter screw, 40 times 2.5. So that's a possibility. 2.5 in diameter, but we need to see if that can fit. So this is the least material that we have, somewhere like here. So we need screws to fit. We could fit one up here probably. Here would be tricky, but we definitely need 2. Definitely need 2. I mean, let's see. If I take this plane, I go to this plane, and then I'm like, hey, I want to fit 2.5 millimeter screw through this whole thing. Okay, so one can definitely go there. the othermost material is right in the middle here. That's not bad either. And now I'm wondering, maybe we only need one going through the middle, and then we have, yeah, why waste time? Use lot screw when few screw do trick. You know what I mean? So let's get rid of the one over here. And if we just have this screw going through the whole shebang, and we have some just like guide pins, I guess you could say. Why not? Oh, wait, what am I cutting through here? There's something over there that I was not thinking of. Okay, I'm gonna make a new body here. Pretend it's a screw. And then we're gonna take a look. Okay, so it's kind of cutting through like this area here. So I did not think about that one bit. I don't think, that's kind of my issue. That other screw position was definitely safe. The only other one I could see would be like up here, but I don't know. I could move it down probably and it'd be fine. But then if it's at the bottom, I probably want, like if it's not in the middle, like the center of pressure, I'd probably want another one. Fine. Or could I make it a lot simpler and have two screws coming in from either side? Does that work? Because I was thinking originally, ignore this. I was thinking originally that this would be like 3 separate assembled parts, 1, 2, 3. And then I would just take one go in, one go in from the bottom, one go in from the top. This one slides in the center, and then it's all good. And then you shoot that screw straight through. But now I'm thinking that we could put a screw through the back here, or a couple screws through the back here, and a couple screws through the back here. So put a couple screws through the back here. Now these are one part, and then you put that in from the top, and then this one can still go in from the bottom. That would work, but then the question is, why? Why do that? The other question is, how cool would it be if we could actually hide the screws, like Apple, like the old days of Apple? But why do I care? Why do I care so much about that? Doesn't matter. Who am I? Steve Jobs? I shower. I'm not like Steve Jobs. I don't smell like Dookie. We're buffering again. I thought we were free of the buffering. I restarted everything. I thought we were free of the buffering. think. There we go. Okay. So he sticks his feet in a toilet. Are you kidding me? Yo, that's crazy. That's insane. Is that real? Steve Jobs. Steve Jobs foot in toilet? We're not reading the AI overview. Soaked his feet in toilet water to relieve stress. He soaked his feet in toilet water as a stress reliever. Got to look at their sources here. So Walter Isaacson is the biography, 14 years old. I remember my dad read this book, and he told me about like the weird stuff that Steve Jobs did. Toilet. There's no other explanation here except, as well as being a sort of genius, Jobs was a truly weird man. As a young man, he was once put on the night shift so coworkers wouldn't have to endure his BO. Oh, Jobs was convinced his vegan diet meant he didn't need to wear deodorant or shower more than once a week. Yeah, that's what I remember. He was perpetually shedding his shoes and sometimes, to relieve stress, soaked his feet in the toilet. His on-off veganism was allied to cranky theories about health. When he rebuked the chairman of Lotus Software for spreading butter on his toast, "Have you ever heard of serum cholesterol?" The man responded, "I'll make you a deal. You stay away from commenting on my dietary habits, and I'll stay away from the subject of your personality." Yeah, motherfucker said your shit stinks too, man. Literally. Come on, that's insane. Gosh, what a crazy, crazy man. Okay, a couple things. We do need to make sure that we push this one and this one that way so that we have some clearance. Excuse me. So, here we go. How can we do this? Yeah, I kind of don't want it in the middle-ish. So here we only have like that much space first. Oh, but okay. But I can use smaller screws. Ah, screw it. I'm going more screws, smaller screws, going in from both ends. That's what I'm going to do. So, let's say we want to, I mean, I have 20 millimeter screws. So, I'd like to think that I could stick this in 6 millimeters or so. So, like, if that's the case, going from here, and they're 2 millimeters in diameter, and if I want 2 of them from each side, I want them relatively distributed and nicely. 2 millimeter screw down here, a little tight, but I think totally totally doable. I'm going to put it right here so that it is the minimum wall thickness possible away. Oh, also, yeah, this doesn't even go all the way in. So it's a cylinder. Remember those? So put that there. And this coincided with that. And that really, what that really means, I also want to intersect here. I'm constantly forgetting. Sometimes I'm like, oh, this is going to be so hard. And then I go at it and I'm like, oh, this is actually a lot simpler than I thought, because I forgot a couple things. Like cylinders exist and in 3 dimensions. And that means depending on the cross section you take, there are a rectangle of varying heights, not the exact same height. Fun geometry, love it. Okay, and so we're going to do like basically like a thread forming hole. 1.9 millimeters, 1.88 millimeters for a 2 millimeter screw, something like that. Do I know those magnetic levitation displays? Do you think you could build a custom one? 2 interesting questions. My first answer is no. Levitation display. Oh, these. Okay, I thought you meant like a display, like a monitor. Some kind of weird new monitor that has maglev in it. Yeah, I could definitely build one of these. Yeah. Cool. My CNC. Yeah, actually, it's a little bit embarrassing. Let's go, if we go to my studio, YouTube studio. I had my video on my CNC last year got a lot of comments from very experienced machinists. Let's see, yada yada yada, yada yada yada, all the way here. And so someone said, "Yeah, you should get a bigger mill." Someone said, um, blah blah blah. Blah 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 blah. Use a single flute end mill for aluminum. Not what I learned. Double flute. Um, strengthen the stiffness of your spindle. Go casting. Blah blah blah. So basically, a bunch of people being like, "Your machine sucks. Get a better machine." Blah 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 blah. I remember one person was like, "Just get a better machine, bro." Um, and yeah, just get a better machine. But if I look for Um, ba-da-da-da-da. Get a better machine. I had one comment. Here we go. This guy, my hero. I have a lot of experience. This is Psy Psycho. I have a lot of experience with running lightweight and homemade CNC machines, and I'm certain your current machine can complete something like that 15-hour clearing operation in under 30 minutes. There's 2 main things I can see that are causing issues. You're moving too slow, and you're recutting chips. You really want a mist lubricant for cutting aluminum. Quick answer is faster passes at less depth and a homemade mist lubrication system blowing chips out. So I haven't even implemented the homemade lubrication system, which is something I plan to do. But just their advice for shallow cuts and small depth of cut. So basically an axial plunge of like 0.5 millimeters, and then an optimal load, which is the distance it cuts laterally into the material of like 0.5 millimeters, and then just increase the speed to something not like at a snail's pace. Because before I was doing huge, big, put the end mill in really far and then cut a big cut, but I was moving really slow. That was my solution, because I've only used these giant like manual mills where you can make these large cuts as long as you're moving slow enough. So I was like, oh, I'll just have to move slower because my machine is too flexible. And so this is the kinds of comments that I appreciate, where they're like, your machine is fine, just like change your technique a little bit. And that versus like all the people being like, uh, all the people being like, uh, uh, oh, you don't have the right equipment, blah blah blah. Why are you even doing this? Like come on, man. Like so, yeah. Just this year, I got a chance. I've had a lot more CNC projects, especially for some of my client projects, and I've used the CNC heating Psy Psycho's advice, and holy cow, it works really well. And I didn't get a new machine. It used to suck. I used to hate it, and now I like look forward to using it. I'm like, oh, this means I get to use the CNC. You know, it's amazing. I don't know if I have. I think I have. Do I have a part that I made? Let me see here. One of the. It's a heat sink. I'm gonna look. So I manufactured this heat sink here, and so it's still not like quality of professional CNC work, but I cut this out in like 5 hours versus what I previously like. This would have taken like you can see the fins here. Hold on. Like it's got fins on it. It's got holes in it. Um, this would have taken like 2 days of operations the way I was doing it before. You know. Oh, yeah, I could build a magnetic levitation display. I mean, I've never tried, but I feel like it wouldn't be that hard. But I've been I've been wrong before. So, who knows? Okay. Yeah, so I'm doing this, and I gotta go all the way out. So this makes it 19. So I think 16 is like is like what I have basically. So if I go to your website to set up a meeting, we could work on one. Oh, yeah, yeah, yeah. To set up a consulting project or just like a little meeting. Yeah, yeah, yeah. I think that would be worthwhile. You would just go for the $20, 30 to 40 minute consultation. Yeah, I'll do a little bit of research beforehand. Why don't you tell me right now before you do that? Because maybe it won't be that difficult. Like, what's stopping you from just trying? You know, because it could be that I have an undue uh, sense of that this project would be easy. You know what I mean? Like, what do you think the main challenge is? I guess I'd be wondering. don't have the experience. The current ones have a floating magnet of around 60 millimeters in diameter. You need to cut that in half while still having a decent weight capacity. So you need a little one. Still having a decent weight capacity and height. Levitation. So, I mean, obviously there's a physical limit here. I can't guarantee, you know, that anything is possible. I'm sure you understand. So if you want to have like a 30 millimeter in diameter magnet, it's like this. This should be reasonable. What kind of weight capacity are you thinking of? I'd be happy to help you work on it. Okay. 400 grams, so half a kilogram. Let's say half a kilogram, so like quarter of a pound, something like that. Am I estimating that correctly? Nope, definitely not estimating that correctly at all. Half pound. Nope. 1 pound. I'm a dumbass. 1 pound. Yeah, okay. So 1 pound. So this right here is 1.25 pounds. It's a lot of matter. A lot of matter. This is 1.25 pounds, which is obviously more than you want. But this is pretty intense. So there's 3 parameters here. There's the weight, there's the size of the magnet, and there's the amount that it will levitate. It's going to levitate, but it's just a matter, it's not going to be levitating for a magnet of that size probably more than a centimeter or 2 even. Maybe. I mean, what do you think? Like, is that desirable to you, do you think? Or is that like, shoot, this is like not what I'm looking for. 400 grams, 3 centimeter diameter. It's a big ask, I feel. I could be wrong. Let's take a look at those again. I mean, this is heavier than an action figure or a shoe. Way heavier. Let's see what this says. That will work. Okay. I'm just curious here. Oh, this one's plugged in. But it's got to be just the lights that are plugged in, right? Not. There's no way they're using like electromagnets, right? Is that what they use? Do they use electromagnets, or I would just use permanent magnets? Why would you use electromagnets for this? Is that crazy? I don't need it. This guy here, 95 problems plus one, he's asking me if it's a project that I might be able to help him with. They are permanent. Cutting edge magnetic hover technology. This is such marketing bullshit. 13 ounces. So so 13 ounces is close, right? It's like almost what you're looking for. Bamboo lab levitation module. Okay, so they do have these electromagnets here. Huh. Interesting. This would be something that I would probably recommend if you really want like a dedicated engineer. I'm your guy. Um, top left kit. However, this is not something that you could book a like a 20-minute consultation for, and I'd have an answer for you. You know, this would require some dedicated hours, I would think. I mean, think about like they built this like we're looking at like an electromagnetic like control system here, basically. But I don't know what kind of. It doesn't seem like a control system. This is the thing that goes in, and it's also powered, right? They use induction to power it as well. That's a whole other thing. That's interesting. So, anyway, it's my 2 cents. It also depends if I'm in your budget as well. Yeah, but if you want, you can send me an email about it. Put my email right here. Yeah, send me an email. You can book a meeting if you want. That's good too. And yeah, should be interesting. Yeah, electromagnets are actively controlled. That's what I see. That's what I'm seeing. It's an interesting choice. It must be driving a lot of power through it. I'm curious. I know you said thank you for saying don't interrupt my current work, but I am curious. If I go back to that Bamboo Lab magnetic levitation kit. Give me some information. I hate these websites with the stuff that fades in. 2 amps. Yeah, it's pretty hefty. Makes sense to lift that much stuff. I think it should be possible though. I think what you're saying should be possible given what I can see. You're trying to just make a smaller version. I think it should be possible. That's what I have learned. And we've built magnetic levitation systems in college, not with the same morphology, but I understand the sort of what it takes, I guess, is what I would say. Okay. These are for my countersunk screws going in there. We're going to have one in there and another one somewhere else. Okay. Up here, right? That was the good place. Couple things. 0.6. No, not symmetric. What am I talking about? One side. Anyway, I'm just thinking about helping this guy with his stuff. That's all. It's not for my project, but it's always good to learn stuff about it. You know. This looks pretty decent. 2 screws going in. There's a clearance hole here. buffering again. Did I finish my coffee? Oh, that's such a shame. I really need like bottomless coffee. I've been trying not to spend money on food. I'm pretty good at that, about making my own food. There were a few months there where I was so broke that I had no choice. But I might have to go get a smoothie with protein from Tropical Smoothie because I don't eat enough food and I work out a lot, and that's a problem, especially when my chatters have been making me do egregious amounts of exercise. Okay, that's the same. And I just got to stay on top of it. But I've got so much work to do. Oh, so much on my plate right now. It's ridiculous. Okay. 5.5. This is it's gonna work. That's gonna work. That is gonna work. That threads into these two holes here. Then I'm gonna do here. Oh well, you know what? Or you know what? Here and here. Go here. Make new body. Then make a midplane. Here, here. Then going to take this. New offset, please. New offset. Thank you. Put on the black rolls again. Okay, and we're going to mirror this body, this one and this one, this way. Boom, we got our new holes over here. Then we get this. We cut with these new ones, but we keep the tools. X-Horse 3D desktop 5-axis CNC machine. Sounds amazing. Probably can't afford it, but it's something to look forward to. X-Horse 3D 5-axis desktop CNC. Looks amazing. Wow. Yeah, something like this I think would be my new CNC if I got a new one. Because that's just so cool. I mean, like, what else can you say about it? It's just fucking rad. Okay. Here. But for now, you know, there's something to be said. I do things efficiently, cost effectively, because I have to, and also because it's good practice too. I'm pretty good at doing a lot with what I have, which is not much. It's a lot for, you know, it's a lot, but it's not much compared to some of the other guys out there. That's why it irks me when people are like, just get a better machine, just get a better machine. I'm like, am I not allowed to be part of this club just because I can't shell out thousands of dollars for new machines? Like, come on. 4.5. No, 4.3. 4.3. And these go in 5.5. And then we chamfer. 1. Okay. That's all fastened up then. That's together. I can't believe it. Okay. These two go away. I get really sad that I haven't finished my coffee. I get really sad. I wish you guys could see me in color because you see this rad Spider-Man Pez dispenser. It's really cool. Look, I've got to get Pez to put in it though. You know, I would love that. I just want to eat candy. Okay. Good. I'm gonna do a little sneaky. Fill it. Right there. I'm curious, 95 problems plus 1, if you're still here, you could probably get a sick, CVS sells Pez? That's cool. You could probably get a sick, like, custom PCB for this maglev design. And I personally think that would be pretty rad. So, if you're interested in that. All right. Yeah, we've got an interesting setup here. I quite like it. Okay. Now, is that everything? That's the thing. Is that everything? Oh, I remember. I remember what else I was going to do. So here's the thing. We've got springs to who created this section view? Who did that? I don't care about that. We have springs, plans for springs to fit right here to compress these pawls against the ratchet mechanism. But I want springs also to actually open up, like act against the closing of this. Because then, like, it's not like you press this button up top. Thank you for your email, 95 problems plus 1. A PCB, a printed circuit board, a custom circuit board. If you're going to have a nice, small, compact, you probably will need that for this, I would think. Since you're having these two parts that are, like, inductively, like, interfaced, not just, a little levitation thing. If you want the power to be transferred over space, that's what you're going to need. So what was I doing? Yeah, okay. So it's not just that you press the button up here and then the ratchet is released, meaning you still have to take your hand off the button to, like, manually move the components up. No, wrong. We're going to have press the button and it goes, and so we need some more springs. Very mechanical, very steampunk. And to do that, should we use tension springs? I have tension springs. I have little tiny tension springs, but I'm not the biggest fan. We could also use magnets, of course. Those take up space if you want them to be strong. but tension springs take up space. The little tension springs are really tough to work with. The only thing, like, I've included them in this design here. Yeah. There's one right here in this cable shooter. This cable shooter really needs to make a comeback, by the way, which it will. But it's just really hard to work on, like, the 50 projects that I'm working on at once. Of course, 50 is an overstatement. We've got like 2 client projects right now, so that's 2. Then we've got the web, we've got Charlotte, which is released as a product. Then we've got the force myography project, that's 5. Then we got the cable shooter, that's 6. Am I missing anything? Those are really my main ones. Repelling is still kind of in my brain, but I'm not really doing anything with it. So, like, there's just a lot going on. Always and never enough. But that's fine. I'm having fun for the most part, so it's totally worth it. Right. So, tension springs. The tension springs would be really effective, though. That's the thing. The little tiny tension springs. I'm going to grab one of them and see how much it can compress. Nice. Everybody send me emails. I love it. Oh, lightsaber hilts. Sorry, maybe that's private info. Any cubic. Oh, 610. This looks sick as hell. Nice work. Hell yeah. All right. Good job, everybody. I have some really smart viewers. Makes me very proud. Okay. Ooh, one more thing that I almost forgot. This button is not going to be flying off into space. No. We need it to stay on the ground. What's poppin', Chonky Bonky 69? We got the Chonky Bonky 69 up in here. 2.57, nice, love it. So I'm gonna go back to just the ratchet assembly real quick, but I've got these springs here. This is how it goes with these designs. You go forward and you're like, all right, I finished that. And then you start the next thing and you're like, wait. No. Wait. You're like, I forgot this thing, XYZ. And then you got to go back and do it. Okay. Damn, I forgot how stiff these were. I've got these really, really tiny springs here. And I've had them for years, and they're really hard to incorporate in projects because they're so stiff. very strong. And like their little hole thing is like dowel pins. How big is this hole actually? Because I have some dowel pins that could work. It's like less than. It's like 1.3 millimeters wide. My dowel pins are definitely bigger than that. Trying to refrain this stupid. Yeah. Are you talking about you or me? I think I can definitely fall into that too. It's just the nature of thinking, you know? Sometimes when you're thinking about a problem that's difficult, you go, yeah, shit, that can happen, you know? Ain't no shame in that. Oh shit, we got $6 toward the goal. Thank you so much, Chonky Bonky 69. Yes, sir. Thank you for suggesting it. Dovetail end stops are incorporated. Let's see. Let's show Chonky Bonky the fruits of his chat labor. So the way I'm planning this out, we got the upper end stop on this right here. Boom, upper end stop. And then on this part over here, you can't really see it. Let me open the this section view. We got the lower end stop right here. So one of them can slide in from the top, one of them can slide in from the bottom, and then these two screws will attach these three parts together, these two screws as well, so that then it becomes one part and both end stops are in effect. So thank you very much for reminding me about the dovetail end stops. Very much appreciate it, and thank you very much for your €6 donation. Okay, let's see here. It's funny how it shows people's handle, you know? And sometimes I feel like I miss people in the chat that I know because the comment name is not the handle. You know what I mean? Like the handle pops up in the chat, but when you comment or like when you look at someone's page, it's like a different name. So then yeah, there might be people here that I'm calling by their handle and I don't know that I've actually met them in the comment section before, you know? So I apologize if I'm not recognizing you. Let's see here. Okay, so end stops are there. We got the end stops. Oh, that's right. I was going into the assembly because this button needs an end stop on the subject of end stops. So the button obviously is going to have a lower end stop, which is natural, but we need an upper end stop. And for that, I'm going to take a look at this shape here on this shape. And I want that upper end stop to be, yeah, somewhere like down here. So if we offset this by 1 millimeter, 1.2 millimeters to be safe. I want to make a hole for a screw. Dang. That's actually going to be kind of tough. Is there a way for me to... Maybe there's a... There's a way for me to incorporate the upper end stop for this button from the other parts that it's attached to, isn't there? Yes, there is. Yes, there is. Yes, there is. Don't tell me that there isn't, because there definitely is. And then I don't have to use more screws, which is great. So this only needs to work when these other two parts are attached, right? Not this one and not that one. And certainly I'm going to hide all of these because I don't like them. And so when these two parts are attached, I'm thinking somehow these include the upper end stop for this button, if that makes sense. Or I'm overthinking this whole thing, but I don't think that I am. I'm thinking. This button, because the problem is this button is inserted like this when it's assembled, but then how does it keep from coming out? If I take a shape, center rectangle, between here and here, there. I could definitely form some end stops. Let's see what happens if I try to extrude this through. It looks safe. How far can we go? Well, that's definitely not safe. Oh, but I don't need the whole thing, do I? No, sir. No, sir, I do not. I do not need the whole thing. Ooh, okay. So, let's try 2 millimeters. What is this? The Paul house. Okay, this is actually kind of the goated method. I like this a lot. It's elegant. Big fan. So this is how it's going to interfere with the button, top and stop. And then can even get away with a little bit more, maybe 2.2. Is Damien still helping me? No, unfortunately not. But we just kind of lost touch. I think the issue was we were having some weekly meetings about a specific project that is still kind of really important that I was really looking forward to his help with. And, you know, he unfortunately, I think he had, I think he had some vehicle damage that he had to pay for. And so I think he just lost, the amount of time that afforded him the ability to work on this, I think. Um, and yeah, it's too bad. I'm still like, I would love to reach out to him, but it's just sort of why I'm kind of like this is why like people are come to me so enthusiastic. They're like, you don't have to pay me. I love what you do. Let me, work for you for free. I'll volunteer, which is great. I love the energy, but I know, and I've said before in this that you just have to pay people to get to get good motivated work out of them. Um, it's just I don't see like another way, and I kind of feel that like about my own, about my own work. Like if somebody is paying me for work, if I think about all the jobs I've had in the past, I'm like, if somebody's paying me for work, I feel, you know, more obligated to care about it. And then it's different like a lot of times, when, you know, so it's different like if I'm working like I had a job sweeping the floor of the machine shop, right? That's like, that's a minimum wage job. That's like, whatever. That's not super motivating. But, if I think about the first time I had like a paid research position, um, I came out of a volunteer research position, and like I came out of a volunteer research position that was not very rewarding, and I go into a paid research position. And even though I was passionate about both research positions, it was like a summer long program, right? I remember being like, wow, they're really paying me for this. Like I really need to like, you know, do my best here. So that's just kind of I follow like my own experience with that. And I just think it's just like a good thing to do in general to compensate people. It's just mutually beneficial, you know. But we'll see. I mean, Damien would definitely be like close to top of list of hirees, I would say. Um, so he's definitely in my address book. Make a new body here. So this is pretty decent. I'm going to cut here, keep tools. Make sure that can slide. And then make sure there's a little bit of clearance to allow for the intended operation of the end stop. And then got to take a look. You know what? Before. Hello? Oh, oh, oh. Okay. I got to look at this guy because this guy also needs the juice. Mm. Mm-hmm, mm-hmm. Okay, I'm going to cut using this and that too. I'm missing something here. Doesn't look like. So I'm going to combine these now. Okay. But it doesn't look like I've added clearance yet, so that's good. Combine this and this now. Okay, then I would say I want to try to make this a little bit seamless from a design standpoint, so bear with me while I copy this and go here, and same thing over here. Copy this, go here. Boom, boom, boom. So, new body. And I'm just going to give it a little chamfer. Combine. Nice. Okay, so we just got to make sure that these end stops can move. First things first. I think that we know we need 1, 2, 3, 4.1, and I should add these on the other side too. 1, 2, 3. Wait, not that one. It should be the bottom one. 4, 5. No, not that one. There. And then we do just this one with the sliding fit. That one. That one. That one. I'm going to give this a decent 2.5. And beautiful. Okay, our end stops for the button have been created. There's not much else to say about that, right? That's it. It looks nice still. It's good. I feel like this needs to be chamfered now. What do we think? Is that too much? Too much chamfer? I'll give it a little less. I'll give it a 0.5. A little bumpy, a little bit spicy, but that's okay. Hybrid design. Yeah. Hybrid design from Toronto. Put it together and also constraints of file or editing. So yeah, so Fusion just implemented. Well, maybe it's less recent than I think. I'm always behind on updates because updating is a fiasco. But they implemented the classic. Hey, yo, 95 problems plus one, $20. Appreciate your content, dude. Thanks so much for stopping by. Appreciate it. I'll respond to your email, and that's very kind of you. And that brings us to $26 for the goal. So $24 left until I have to do a minute-long handstand. So maybe I should start warming up my shoulders. Thanks so much for stopping by. That's very generous of you, and it will not go to waste. Thank you. Oop. What just happened? Okay. That was weird. I've never seen that before. Okay. We got the end stops here. Okay, yeah, so I was talking about constraints. So yeah, I love the hybrid design because you can form your bodies and then form the assembly with your components, and then I'm very used to, instead of the constraints that you typically have in Fusion or SolidWorks, which are actually like probably more general, so it allows you to create better, the more realistic relative component movement. But the joints is what Fusion 360 has had for a long time. That works really well in the hybrid design, and that works for me most of the time. So no, I don't use the constraints. I use the joints still, but maybe I'll transition back. Yeah, I know how to use it, but the hybrid design, I think, is much more versatile and intuitive for my design process personally. Um, so we're gonna do, because I think that's that. I was talking about something. I saw. No, I wasn't. So springs. Springs for everything. Maybe we need a nice strong spring. You know? Maybe it's necessary. Who's to say? Who's to say it's not? It's very strong. Like, this is something you'd expect in like a metal assembly. Let me grab one of my dowel pins, see if it's reasonable, because if so, then I'm going to use that. And I like the springs. I like the springs. I do like the springs. I like the springs. So a couple of days ago, I streamed, and we reached 2 workout goals. First of which was 60 pull-ups, which was a lot. And then, how long have I been streaming now? Has it been a minute? It's been a minute. This goal's almost over. We got 4 minutes left. We might not reach it, which is good for me. And it was 60 push-ups, and I had already done like 100 push-ups earlier in the day because I did the 100 push-up, 50 pull-up challenge. And so I was pretty sore, and I'm really feeling it right now. So these springs in these dowels, you know what? That's kind of perfect. I'm not gonna lie. Do you see this? You can't really see it. Yeah, you can see it. The spring, the dowel goes through the hole for the spring like perfectly, and it's a little bit tight, it's a little bit undersized, so it sticks in there. I can just put the dowel pins in here and then assemble. I'm gonna have to use these. I'm not gonna lie. I'm gonna have to use them. Has to be done. All right, then the question is how. Let me get one more dowel so that I can see what this looks like. Spider 610 gotta leave soon. It's fair. Oh. Yeah, he's got his work, his job. He's a working man. Okay. Let's see here. Okay, I'm feeling confident. The only thing I'm wondering is if we're gonna have too much stretch. We should really put this as close to the axle as possible. CAD Inventor School. Yeah. That's exactly the same. If you were in Project Lead the Way, so was I. That's from high school, of course, and then in college we used SolidWorks. But yeah, I mean they're both useful for a lot of different things. This is a spring. It's just I have a bag full of them. I've had them for like 2 years now. No, not 2 years. What am I talking about? 6 years now. And I've only used them sparingly in projects. You can see them throughout some of my videos. A really small, like 2 millimeter diameter spring, tension spring that is really, really stiff. And so it makes it difficult to find places to use them. But I think this might be one. Only thing that's tricky is if we think about it, we need a 15 millimeter stretch here. And that's probably not going to be possible unless we gear it down. So that might be the way to go. A little tiny mechanism to gear down this little tiny transmission to make it so that we turn like 4 millimeters of stretch into 15. So it looks like we can reasonably, if this is originally like 10 millimeters long. So how far can I stretch it without it plastically deforming? Reasonably. Fuck. So really hard. Okay, it looks like can't fucking do it. It looks like 5 millimeters is safe. Okay. So let's say 5 millimeters. Mechanical advantage, but in this case, mechanical disadvantage because we're going from a very stiff, short distance, and when we gear that down to get more distance that force can be transmitted across, we're going to get less magnitude of force, less effective stiffness. Okay. So let's think here. Let's go for the rotation first because I think that's going to be easier. This was 67 degrees. The magic number. I feel kind of bad the goal failed, and you guys contributed so generously to it. So what I'm going to do is next time I stream, it's still going to be level 3 1-minute handstand, but I'm going to start the goal at $25 instead of $50. So it'll be more achievable. And this is coming from somebody who really does not want to do a 1-minute handstand, by the way. This is not my strong suit. I will be doing it against the wall. I will be struggling. You will be hearing me scream. I will be grunting. And we got to make sure to stretch for the next couple days because it could happen. Mm-hmm. Okay, so that's where that's going to be. Need a section view. It's also like where will this go? You know? Save that money for DoorDash. That's right. Save that money for DoorDash. I'm not. Do not give me money if you're saving money for DoorDash. DoorDash is way more worth it than whatever the fuck this is. You'll do one with me. Nice. Love to hear it. Yeah, you've been working on that. The 1 minute handstand. Okay. Let's see here. So I'm kind of thinking, right? Like we are going to need a little subassembly where this spring sits. And that's right. I will need the support. I will need the moral support. That will be very important. So a little assembly where this spring sits. And to me, at least, it makes sense for that assembly to be, first of all, as close to the center of this as possible so you don't get a lot of unintended moments. But there's too much going on in the center here where that ratchet and pawl assembly is, that pawl with the springs and the release button and all that stuff is. There's too much there. So it's got to be, spring will be like just to the side of this assembly, either over here or over here. Which means that the way that this will be assembled is either, if it's over here, these two get assembled, then that gets placed in, then the pawl assembly, then this component. Or if it's attached over here, this part gets in, then the pawl assembly, then this little sub-assembly with the spring. So which is better? Which is better? Why couldn't you go to the hardware store with my $6 and buy some springs? Then you wouldn't have to kill yourself on the design. Because I want this to be really small, and I have some really small springs. I don't think the hardware store has springs that are 2 millimeters in diameter. I'm pretty sure they don't have that. And I know that these springs will work. It's not so much a constraint as an opportunity, if you know what I mean. Plus, maybe I need that $6 to buy DoorDash. Okay, if I'm thinking about this, I want wires. They're going to be wires because here's where the PCB is. The wires go through. Da, 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 da. I want them to go through here. So I want more space over here for the wires to be able to go through there. So I want that mechanism to be over here. I think it's going to be on this side. That's what I've decided. The satisfaction of something finally getting a use. Exactly. You get it. It's also like the other question, right? Is, you know, I know you don't mean to judge my design choices, but I'm just saying, the idea of being like, oh, I'm so constrained on the design because I'm forced to use the components that I have. No, because there's actually so many different decisions you can make on a design. So it's not so much as a constraint as a decision made for you, and then you can just move on. You know, so you don't spend too much time thinking about what's best, what's the absolute best type of spring or system I could use here, because that decision is made. You got to go with it, and then you move on. Because so many things, so many different decisions could have the exact same output. you know. So sometimes it's better to just choose something, and this is one of the ways you can do that. So if that's over here, right? Because I want the wires to pass through here. I think that's like the only way. That's like the only way. And it might get tricky, like once I actually have to put the wires through. But I could have a connector. I could have a pretty rad connector sitting somewhere so that it's disassemblable. I think that's reasonable because I have connectors. They can fit inside this extra space here because there's going to be PCB and battery in there. Yeah. Okay, so what I'm going to do, hide these. And this and that. So spring is going to be between these two components here. And basically got this to work with on this plane. It's going to be indented in here. Somehow. Why is this like, I don't like that it's, okay, 0.1. Okay. Yeah. A simple bushing can be used instead of an SKF ball bearing. Yeah, exactly. Let me just check real quick. Okay, of course. I need to see where this has ended up. Just so that I don't end up shooting myself in the foot. Where this PCB will sit once the door has been opened. There, okay. Good. Okay. Mm-hmm. Okay, here's the plan. I need some food. Don't really have time to make it. I also need some caffeine. I need protein, caffeine, and some food. So what I'm going to do is I'm going to pause, pop down the street, spend a quick $10 on a smoothie and a wrap, small wrap, and I'm going to come back. But I'm going to leave the stream running. So what can we do? We can watch a video of mine in the meantime. I don't know. Whatever. I'm going to come back though. I promise. This want to see if the PLCI is cut out. I don't know what they said. That's a good one. I don't know, man. Let's go here. Just remind people.
This is a wrist-mounted grappling hook, but it's just a milestone project. Something that allows me to understand a technology on the road to something greater. Think about what it took to put a man on the moon. We had to master EVA, docking, and LOI before Neil Armstrong could ever take his first steps. Eventually, this device will be scaled up, but not too much, with a human supporting cable, a sound structural base, far faster motors, and an intelligent hook design. That's a ways off, but there are steps we can take right now, in this video, to make this problem easier to solve. The last video in this series demonstrated initial testing of the first fully functional prototype. But as cool as this was for me, I could see how these tests would produce little more than a quaint meh for some of you out there. Short rope, a little low on the power side, I get it. I even had a longtime viewer and supporter suggest adding a coil gun to act as a supplemental propulsion source. Don't worry, we're gonna get to all of that. The mathematics is the key to understanding what it takes to make this design more effective. And when I say more effective, I mean much more effective. But the mathematics isn't always what it seems.
What?
Hey everybody, welcome back to episode 1 billion of turning all Spider-Man fans into engineers and all engineers into Spider-Man fans. So this video is sponsored by Dragline Dynamics. Hey, wait a minute, that's me. Me. That's right, this one is on the house, but I do have to tell you about my company, Dragline Dynamics. It is the banner under which I am doing all of this scientific research. It's all about making these really fantastical products super accessible, super effective, and available to consumers. We're democratizing technology for modern heroes. So if you're one of those real-life superheroes out there, you might be interested in having me make your custom symbol as a symbol light. That is a thin, flexible lighting fixture that you can fit under any garment, and it basically turns any garment into a hidden, transformable supersuit. If you want to use this brain, I offer engineering project consulting. That's for those of you who are running your own kind of startup. Can help with developing prototypes, writing code, and if you are in school and you are struggling with math or science, physics, whatever, you can hire me out as a very cheap tutor. That's $20 a session. It's the cheapest and most educated tutor you could possibly get. That and Charlotte Mark 1, my 8-legged robot, will be shipping soon. That's all it is. If you want to head over to dragline.tech and check out some of the services I have, that's my company, Dragline Dynamics website, dragline.tech. Let's get on with the video. So last time we went through the incredible journey to this incredible electromechanical design, and now let's go over how we can rigidly attach these 3 modules together with a super aesthetic cover. Take that with as much sarcasm as you want. First thing we got to do is take the straps off the old cover here. Bad cover, terrible design, really awful. Okay, there's the straps. I also want to show that these modules can be screwed together so you don't have to rely on the electrical connections to hold them together. So now it's nice and rigid. These parts are mechanically constrained as well as electrically constrained. And let's get to the cover. The cover consists of 2 parts. First is this part, which is one single part. It slides pretty simply over the front. The FSR trigger pokes out the front. And in the back, it fits under these 2 overhangs here for a snug fit. Just like that. Then I have this really nice 3D printed cover here. This is PET G, which is slightly flexible, and I printed this in multiple segments so that it can be folded up into the right shape. See, originally this surface was on the build plate, but it's folded now, and this one just pops into place on top, and there's just a handful of screws. So now you can see it's completely covered, and we're gonna go ahead and add the straps here and here. And there we have it, all the straps attached. Let's put it on. Okay, now this feels pretty cool. I can already tell that this version is special. This version is different from all the other crappy versions. The old crappy versions I'm talking about mostly consisted of terrible capstan pulley-driven mechanisms. There were some decent ideas in these old designs, like this one where I had this arm move back and forth to organize the rope on the reel. Feasibility-wise, this just didn't work with the rest of the design. Wait, you don't even know how this thing works, do you? First, watch closely. We turn this on. Initially, the light is blue. That means this is in winding mode. To move to firing mode, we have to charge the spring. So we double tap the trigger. Now the spring is charged. Now the light is yellow, meaning we're in firing mode. To release the projectile, we press the trigger again, hard. And you can see in this state, it's super easy to pull the cable off of the reel. Now the red means that the cable has been fired. To bring it back to winding mode, which is the blue light, we double tap the trigger again. And we can wind the projectile back in. And it perfectly resets itself. Let's go over the mechanisms here. Let's demonstrate the winding mechanism first, because that's the easiest to understand. The winding mechanism is driven entirely by this motor here, and it consists of a simple gear train, one bevel gear to another bevel gear, and then this interestingly shaped gear here, which you can see is now decoupled. Now moving from firing mode back to winding mode with a double tap brings this interestingly shaped gear, which is fixed to the spool, into contact with this bevel gear. And then we just press the trigger to wind the rope onto the reel. Pretty simple. Now for launching the projectile, first you can see the spring is being charged because this part is moving forward. At the same time as that part moves forward, the spool moves this way to decouple from the winding mechanism. Now all of that is driven by this single motor. The first thing I'll point out is this gear. That's the input gear of the whole mechanism. It gets rotated by the motor. That gear rotates this long gear in this system here. That long gear, in turn, rotates this gear, which has the same number of teeth and shares an axle with the input gear, but is not directly attached to it. Now there are two screw mechanisms at play. One screw follows a nut embedded within this long gear here. That screw provides sufficient mechanical advantage, enough to charge the spring, which requires a lot of force. You'll see that the screw doesn't rotate, but the nut embedded within this gear does. Same thing is true for this smaller screw. There's another nut embedded within this gear that runs along this smaller screw. That allows this slider to move back and forth as this gear moves back and forth, albeit much more slowly, due to the differing pitch in the two screws and the gear ratio. As this gear moves and runs along this smaller screw, you can see it pushes and pulls this body here, which does not rotate. That body is attached to two arms, which change the direction of motion at a right angle to move this spool back and forth. This right angle motion coupling was one of the hardest things for me to get right, and I tried a bunch of weird things, but these two arms being here actually ended up being the perfect way to do this. So that's how we couple the motion of the spring charging with the motion of the spool decoupling. How does the projectile actually get released once the spring is charged? What would normally take another third actuator to drive this latch, which releases the projectile, is replaced by a simple mechanism in which the spring is charged by this slider moving forward, and then the slider simply moves forward more to activate this latch. You can keep the spring loaded before firing because this limit switch is triggered by the slider. Now the spring is charged, and we're ready to fire. You may also notice that this rope is being wound very tightly around the spool. That is key to the proper operation of this device. It maximizes rope storage and limits vibrations. And you can see if we take this segment of rope between the reel and the nozzle, it takes quite a bit of force to pull the projectile out. And in fact, you can see the force of gravity on this projectile is not enough to bring that segment back to being taut. That is because of a strategically placed tensioner that is activated by this line here. This tensioner is returned to its normal position by this spring here and allows there to be proper tension on the rope during winding. But as the slider moves forward, this cable pulls on the tensioner and it is released, allowing rope to be pulled cleanly off the reel with no resistance. Strategically placed electrical contacts allow the system to know when the slider is at its limits. These contacts have contacted, and that acts as the limit switch for this slider. Pretty cool. Let's test it out. That's so tight. That's tough. Look at that. Whew. So we're going to need to make some kind of trigger holder, that's for sure. Let's see. It still works when the cover's on. Okay. I'm going to firing mode. Firing mode. And then let's fire. The key principle of the launching in this design is this incredibly stiff spring. Helical springs like this are defined by a spring constant, usually called K. The force that a spring exerts will always be K times how far you push it from its neutral position. It's a linear law of elasticity, called Hooke's law. Most importantly, this spring stores energy, elastic potential energy, when compressed, equal to this quantity. Ideally, when released, all of that energy gets converted into the kinetic energy of the projectile, since physics and thermodynamics tells us that energy cannot be created or destroyed. You following me? Energy stored, energy released. Easy, right? But some energy is lost. Some energy leaves the system. Friction between the projectile and the air, between the rope and the barrel, between the spool and the axle, all friction creates heat, and that's energy lost. These are inefficiencies. The efficiency of the system is the actual amount of kinetic energy the projectile is imbued with, divided by the amount of elastic potential energy stored in the spring. This number can never be greater than 1, aka 100%. I want to draw a comparison here with a more common method for devices like this. That brings us back to this comment. So, what's a coil gun? A coil gun also uses an energy stored, energy released principle, only with electric and magnetic fields. A capacitor, remember the last video, becomes our spring and stores electric potential energy charged to high voltage over some amount of time. The energy stored equals this quantity. See how it's a similar equation? This capacitor that I have built coil gun type devices with before can be charged to 400 volts safely and has a capacitance of 100 microfarads, meaning it can store close to 50 times the energy that our spring can store. That's crazy. Coil guns are definitely much easier to build, and they have no moving parts. So why am I not building one? Coil guns are inefficient, like extremely inefficient. The projectile has to be ferromagnetic, i.e. iron, and it sits at one end of a solenoid, basically a coil of wire. When the capacitor releases its charges as high current through this coil, a magnetic field is created, forcing the projectile towards the center of the coil. And if the timing is just right, the magnetic field shuts off right as it hits the center, so its inertia carries it beyond the barrel. That's the potential energy transfer in a coil gun. If the timing isn't right, the magnetic field pulls backward on the projectile as it leaves the nozzle. Inefficiency. The high current in the coil generates resistance heating. Inefficiency. The magnetic field generated is also a different form of potential energy, and only a small fraction of it is affecting the projectile. Most scientists who work on coil gun construction are building these really giant designs made with these giant capacitor banks. Now, the larger a coil gun gets, the more efficient it will be, and these scientists are typically reporting numbers around 10 to 30% efficiency. But we're talking about a coil gun that is wrist-mounted size, and everything I can find on that subject means we can expect an efficiency of around 1 to 5%, if even that. So let's say we have 1% efficiency for a coil gun I could build to have the same profile as this device. That's probably too high an estimate, given I'd need to fit a coil in this too. That means we need around 50% efficiency in our string launcher to compete. And there's not that many sources of inefficiency here if you ignore the rope. Just a really small amount of friction and air drag. It's because of this that I'm confident a spring was the right choice for this device. But I will say, the current needed to charge this capacitor is much smaller than the current needed to charge this spring via the motor in the same amount of time. You can even feel the motors get warm. So coil gun, extremely efficient charging, extremely inefficient launching. Spring launcher, extremely efficient launching, and somewhat inefficient charging. Also, you might want to head over to my Patreon at patreon.com/theamazing. The work that I do isn't cheap in money or time. Really, just $1 a month helps so much. But just how efficient is my wrist-mounted grappling hook? Without the rope, I'm guessing close to 100%. But with the rope is a whole other story. The rope doesn't always pull all the way out, and I've only got like 2 meters in here, even though there's clearly room for more. So if I decide to add more, it's probably not going to matter too much. Wait a minute here. I wonder. In a super random moment of curiosity, I decided to see what would happen if I added an extra magnet to this projectile, increasing its mass, and the string pulled out all the way, every single time. Wow. It really works every single time. I can prove that increasing the mass of the projectile increases the range of a system like this.
And I can prove it with math. Okay, so the first thing we do is define some physical constants. We've got the spring constant, we've got the initial spring compression. Those are all things that I've measured on the actual. There's me talking about some some bullshit. Okay, so got my food, thankfully. And it's your friendly reminder to go outside, especially if you're in Southeast Michigan, because god damn is it a beautiful day. Once you have the PCB slot cut out, it's time to start thinking about wire management. Yes, yes, yes. You should heavily fillet nearly all the outer edges. Heavily, no. A little bit, yes, or chamfer. But it depends. This is like there's like a cross between, or some balance between look and feel here, for sure. Oh, yeah, my burrito just fell in half. Do they cut these now? Huh. All right. You guys don't need to hear me chew. All right, let's see here. So it's exactly like 8 millimeters in rest distance, this spring. I'm just going to draw an 8 millimeter line. Okay. Give this like a 2.5. So this is essentially like where our spring might go. And I want it, it's got to be close to this axle, because we don't want it to exert like a really high torque, high force, but we don't want this to be like, possible to close. We don't want it to stretch too far. So we said we can get 5 millimeters of stretch, right? So I mean, 5 millimeters of okay. Let's just do the calculation. 5 millimeters of stretch would be the arc length. 67 degrees is the angle. So the radius is what we're looking for. 67 degrees to radians. Okay. Arc length divided by radians is radius. 4.27. Okay. So if it's 4.27, and just to test, actually, we can do an arc, center point arc between here and here, 67 degrees. All right, that looks about right to me. Is 60? Yeah, I mean 67 degrees is really close to 1 radian, right? That's funny. 1.16. So basically just 1 radius across, a little bit more, but so that's the nominal. Negative 1.2. Okay, see, there's the problem. That we eat into the screw. Could probably go a little bit longer than 5 millimeters and still come back to the rest position, right? That's what I would think. But there's also sort of the idea. So let's just say like let's just say we're looking at our spring here, and then in the stretched position here. I'm going to make this a driven dimension just so I can observe the length. And this one here is 10. Oh, wait a minute. I'm silly. I'm silly because 4.25 should be the radius, which means 8.5 can be the diameter. So we can even do less than that. Let's go for offset negative 1.2. Let's go for 1.5. Why the hell not? 1.4 even. Okay. And we need that similarly in the other direction. So I'm basically tracing out, where our spring will travel if it has to wrap around this screw at all. Buffering. Okay. Oh, it doesn't give you the option to do a driven dimension unless it has to. That's dumb. Okay, I'll delete that. So I'm thinking something like this, right? Where it's pretty much all stretch. Yeah, why not? It should be all stretch, right? The tension spring. Let's try to make that happen. The distance between here and here is, I'm just curious, 4.691. And then the distance between here and here, 8.663. Let's make it 8.5. And suddenly, we have a place for our spring to go. From here. Oh, good Lord. Lord Almighty. Nope. Of course, it's unsolvable. Okay. I'm going to draw a new slot for the place where our spring will go. .8, really. Hey, man. Huh. I hate when they do this. I'm just trying to rotate this thing, dude. So, I mean, like, it really seems like we can just put this spring right in here. If you make it simple, let's try horizontal. No, but then it's not, it doesn't stick into this enough, you know? I don't think that's the right way. So if we project that line, I would like there to be adequate clearance between that line. Let's say 3 millimeters. Can it do it? Yes, it can. And we're passing by this hole. Let's say 3.5 millimeters. Can it do it? Yes, it can. Now we're closer to this hole, but the spring isn't going to interfere. But I still like to have there be some clearance. So we'll try 3.2. 3.125. Why not? Okay. Mm-hmm. Mm-hmm. Because then 1.5 is the diameter of my pin. That seems like like that hole size will work there. You know, there's not too thin of a wall. I think that will be good. So that'll be that pin. And then that'll be that pin. We got to make sure there's enough track for both of these things here. Because we know it's going to end up on the line, but it needs to like be on the line, I guess, if you know what I mean. So I'm just going to make this slot a real thing that we can extrude by eliminating construction lines. Great. Then I want to take this and relative, you know, I want to see what that slot should look like when this is rotated the other way with respect to um, the little door, the door thing, you know. Okay, so I'm gonna copy paste, rotate around this 67 degrees. Yeah. Yeah? Yeah. So that means that, is this a straight line? It really should be. Or parallel lines. Yeah, they're parallel, which is exactly what they should be. So that means that the shape we need to cut out from the door and this and that. Okay. Nothing changes. Great. Yeah. This is good. This is good. That's the cutout right there. So if we go negative, -1, -2, -2.5, should be enough space for the spring and stuff. Mm-hmm. Okay. Then, I mean, there's kind of no reason to have the ratchet over here. You know what I mean? It's kind of silly. So I'm going to see if I can get rid of it. New 10.5. New body. Hello? Hello? Okay. That was a good burrito. Chamfer. See what I'm doing here? Trying to eliminate those sharp vertices from the edge of these ratchets. What progress statement was to receive it? Oh, dude. As soon as I can. It's just like, it's just not, it's just not repeatable enough. You know what I mean? That's really the shame. Um, it's just not good enough. I'm gonna make it good enough though. Just one of, several things. I'm excited about it still. It's just, with the Charlotte orders coming out, I'm excited for Sensational to get this one, but it's proven tricky even now. Definitely made a lot of progress at the beginning of this year, but there's more. There's always more with that one. Okay, good. Sorry, I'm just cleaning some stuff up here. Dude, I don't mess with the feature tree. I'm built different than all you other CAD engineers out there. Don't mess with the feature tree. I do sometimes, obviously, because it's more easy. I do the easiest method always, what I think is going to be the easiest method. Okay. So I wanted to see. Yeah, it's been too long. You know, I agree with you. Totally agree with you. You just you don't know how it is. It's like good, but I really want I really want Zach to get something that he can really show off. You know, like I really don't want to give him something and just be like, like whatever. I guess I'm done. You know, that's not cool, man. That's not what I'm about. All right. And this is, you know, this is for research purposes. Like I'm trying to learn about these mechanisms. Okay, so this is constructed in such a way where there's always going to be, at least I think. Let me see. Let me test that hypothesis. Hmm. No, I'm wrong. I should probably cut this out too, but that kind of sucks. Guess it's not a big deal if the spring has to like bend a little bit, but just a little bit. Yeah, like that should be fine. That should be okay. I'm going to do some fillets just to make sure we're not getting any excessive rubbing of the spring on sharp parts. Okay, now I'm a little bit afraid. A little bit afraid that I didn't. Okay, that was 33 degrees, right? Which means I'm just trying to keep track of the position of this thing. Which means this should be another 34. Yeah, that looks right. That looks right, right? Did I? Did I? No. No, 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 no. I just need to see. If I measure between, if I measure between here and here, it should be 4 degrees. Yeah, okay, perfect. Yeah, no, 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 you're absolutely right. So that's going to be an SLA print. The teeth are very small for the ratchet, yes. So I've made them hopefully a comfortable stereolithography size. Yeah, and you'll see I've got a new SLA printer, so I'm hoping for high quality. Yeah, this looks good. Spring between there and there. That's it. So we just have to get the rest of the details here. The first of which will be um, a 1.6 millimeter hole and a 1.6 millimeter hole. These are for the dowel pins, which they're actually imperial dowel pins. So actually, like, yeah, they are 1.6 because they're a 16th of an inch. Should those be press fit or not press fit? I have my concerns about press fitting them, but I also have my concerns about not press fitting them. I'm gonna go with not press fit to start. I don't know. Is that dumb? I don't know. Either way, 1.7 will probably be fine. Okay, then we love imperial. Love is a strong word. I suppose I should since I'm in the US, but I mostly work in millimeters, as you guys can see. Mm-hmm. 0.8. Like 0.8 there. And then some deeper holes. Getting a little bit fantasy brained. What is this disgusting? Ugh, gross. Um, I think in this case we can, I'm getting some longer ones, so maybe I'll start using those. I'll go 1.5 millimeters. I mean, no target body found a cutter intersect. What are you talking about? Huh? Ridiculous. Oh, yeah, that's a good idea. Oh, God, I don't even. Metric for life. Now, what's your opinion on temperature? This has become quite controversial lately. Come on. I'm really tired of the buffering. Come on, Will, get hyped. You've got a a killer, a killer smoothie. You're working on CAD. You've got Shira Segev and Chonky Boy 69 in the chat. It's going well. You're nearly done. You just need to figure out how the hell to get these springs in there the easiest possible way. Okay, so that's the thing. This cuts into there. Okay, I got to go backwards a few steps. I think I've lost the plot a little bit. I think I have lost the plot just a slight amount. Okay, feature tree. Take me back. Take me home. Country road to the plain. I belong. West Virginia. Mountain mama. Take me home. Country road. Okay. There's space for the spring. I will acknowledge that. The spring will be visible, which is not my favorite thing. It's really not my favorite thing. but there's not really much that I can do about it. You know? Okay. First of all, delete features after history marker. Okay. Hmm. That's my spring. Rick, by the way. Cool. Thanks, Rick. That's much better than Chonky Bonky 69. Gosh, why is this giving me so much strife? The spring goes there. We know that it will have to. But think, okay, we've got the profile, maybe. Let's just say we do. Let's look at this in all 3 dimensions now with all the bodies that we're going to need to account for. So I'm saying spring goes right here. It's kind of still hidden, right? I think that's okay. There's not much we can do about it. But is there? But is there something we can do about it? You know what I mean? What if I use this compression spring instead? What if I did that? What happens then? Is there room for it? There might be room for it though. And then I don't have to worry about mounting it because it seats itself. Let's just look at the geometry, okay? So like say we use the compression spring, okay? I think so we've got a maximum travel for that. Starts at 17 millimeters, goes down to 5. Okay, 12 millimeter travel. Jesus. Which also coincidentally means it's, if we're thinking ahead to the stretchy one, or sorry, the translational joint, it's too long for that. I've got this one that's twice as long. It's also twice as big. Well, I mean, it means we'd have to fit it. It's twice as long? Yeah, it's twice as long. Which theoretically means the maximum travel of this one would be 24 millimeters. Jeez. It's hard. Okay, let's think just for this, the rotational one first. I want to think about this. Like, imagine this shape that I coincidentally made for the other spring was actually a little tiny, um, like lever that stuck out from the rotating part. And what would that look like when we go from this position to 67 degrees clockwise? You know, what would that look like? So I'm thinking about this line here, that surface, copy, paste that, rotate that. Okay, so definitely will stick out. Not crazy amount, not a crazy amount. It's not insane. And I'm wondering if I take this and I offset that by 1 millimeter, which means take this and offset that by 1 millimeter. It could be like that instead. Then, of course, it's kind of a weird shape for a compression spring. I don't know how achievable that would be. Compression, you have to place it under. Yeah, so the compression spring, I'm thinking, between this line and here, something like that, a force spreading them apart. And I don't think I need two springs to balance the load because it's a very long axle here, so that balances the load. And then all this spring is doing is generating a moment. I mean, what I'm really looking at, like if I can get away with being like having lines that intersect the center, it's kind of necessary if you're going to put a compression spring like in an arc configuration. You need its endpoints to intersect the center. Otherwise, it's going to be wildly unbalanced. So 67 degrees. Okay, what can we get away with here? I mean, let's give it like a similar. Well, actually, to determine, we know what our triangle has to be, right? If the maximum travel is 12 millimeters, and if we can get away with less, that's better. So 11 millimeters, and 67 degrees, very close to 1 radian. So we might as well try to get a radius that's just real close. 1 point, so a radius that's real close to the maximum travel, so we can go for 10. 10 millimeters travel. Let's see. 10 millimeters travel. Okay, so 10 millimeters travel. I think this is probably going to be better. Parallel with the center, intersecting the center. Intersecting the center. The lines that I've drawn here intersecting the center of rotation should become the endpoints for the spring. And the spring will be guided along that arc track by, solid material that it'll have to slide against, but it shouldn't cause really an issue. And this spring is, what diameter again? 5.6 in diameter, so 6.5 should be good. So 3.3 there, and 3.3 there. This saves me the headache of having to deal with the um, like the dowel pins for that tension spring. You know what I mean? I feel like that's so worth it. Like I was like, oh, but it needs to be small to save space. But I know when I build this, I'm gonna be like, oh, messing with these little tiny components, and it's gonna be really frustrating. And I just don't want to have to do that over and over again. So yeah, this is gonna work. This is totally gonna work. And it's totally hidden now, you know? And you're right that I could do two springs, one on either side of the pawl assembly. Be kind to your future self. Exactly. Exactly. So here's what I'm going to do. Make the shape of that spring. .3, but now it's eating into there, so we can offset that by -1. Yeah, why not? And we can make it symmetric, and we make a new body. Okay, so now let's check this out. This is the shape of the spring. If we look through, is it going to mess with anything? Doesn't look like it to me. Okay, great. Oh, okay, I forgot a little shape. Oh my gosh. Oh, I just got a massive headache for some reason. Okay. That's the kind of profile that I want. And I'm going to extend this here. I'm basically making the shape ready to be a tool to cut stuff. Yeah. Yeah. Then what I want to do is get rid of these shapes that I cut before, because I don't like them anymore. Not even one bit, not even close. Yes. Back to that section view. Yeah. This is exactly what I want. We're splitting this body with this body. Do not keep the tools because I don't care about it. Okay, then we got this. Nice, good. Then we need space for like the thing that's gonna be pressed on, you know? So if we think about it, the spring, let's do it this way. The bottom surface of the spring first, easy. We'll make a little like hole for it, 6.3 millimeter hole. Have it go down like just so it can be seated, right? 0.5 millimeters. Is that crazy? No. We need a little bit less because we don't want to extend it too much from what we planned. It would be. Hurry it up a little bit. I don't know, maybe just hurry it up just a little bit, perhaps. You guys listen to that new Olivia Rodrigo album? That's all. It's stuck in my head right now. I'm a zombie in my body. I'm a train off of the track. I feel dirty. I feel rotten. And the colors, they're all flat. Okay. Should be good. Little spot for it. I'm going to give this extra space for like the plate, basically, that it's going to stick against. Okay, 2 millimeters, too much. Understood. 1.5, doable. 1.5, doable. It's the new Olivia Rodrigo album. Look, I know it's music for women, but she kind of goated for real. So we need a some kind of thing that sits in here. That slides. Hmm. Mm-hmm. I think this is the way to do it. Great. I can't believe I was going to do this with the tension spring before. That seems so stupid now. Okay, then we got to make another little seat for the spring in here. Now, this is probably an ellipse now because I did not care. About projecting it onto a plane that is coinciding with the axis of rotation. So it's one of those, one of those conic sections, as you do. Okay. So what did I do for 6.3? It's a little bit much. 6. 5.9 will probably be enough. 5.8 is probably good. What is it actually? 5.6. This is like a press fit, but it's a spring. It's not supposed to move. And that can go C there. Okay. Then we just got to attach it. And then there's actually no reason to have this wall here. That needs to go away. Yeah, but then the force can't travel as far, you know? They have to be, like, I'd have to have them be really close together to oppose each other across. Because I've got to have them, oppose each other across this whole angle. So they have to be really close to the axis or really strong over here. So if they're really strong over here, like you could do that. They might be too big, and then also the force magnitude probably wouldn't be as much because we're talking about this spring, but compressed like halfway, and then wait a minute. Shit. Okay. So I forgot one thing. One little thing. Is that this spring's minimum compression is 5.08 millimeters. Okay, so that's not even in a... What am I doing? What's going on? It's this one's the problem here. Let me finish this sketch real quick. I gotta go back to this one. Fix a dimension. This should only be like 1.3. That was too thick. Oh, good lord. That's why I don't mess with the feature tree. What the hell? Oh, come on. Unbelievable. Okay, there we go. Okay. So now let's go back here. Probably did something wrong at some point, but whatever, it's close enough. And then this has to go an extra. Fuck. 5.5. Okay, what the heck? Okay, so we screwed up. How could this happen to me? I made my mistakes. Okay. 5.08 is the minimum. We cannot achieve that. Or can we? How can we? How can we achieve that? Move it farther away. Because, you know, right now, what do we got? There's a new 3D printer enclosure going. Oh, thanks for the reminder. I never started the print. Give me a second here. Okay, be right back. Okay, we're on it. My brain is not braining. I'm sorry, guys. I'm sorry. Sometimes I can't do it. that's there. If I trim this and trim that, and I want to measure this, 11. So that's also close to the maximum travel. And we can't fit this spring in here. Dude. Dude. I was so excited. There has to be a way. It's not that big. The problem is this requires so much travel, comparatively. Okay, we got to start over again, but we've got to figure out, we got to look at this from a different perspective here. Not from here, not from here. Okay, maybe after filling in my holes before this cut. Yeah, okay. Okay, got a clean workspace. Cut the spring. Yeah, but then the maximum travel also decreases. So we wouldn't have the same like extension amount that we need. So when you cut the spring, you're changing the minimum length and the maximum length by the same amount because they're all related to the number of coils. So we could cut the spring and then move it much closer. That's something that we could do. Let's just take a look at what kinds of geometries are possible. But I also don't like cutting springs because it's annoying. Force to make two. Yeah, but it's not so much about the force, it's about the maximum travel at which force can be applied. So for instance, like I've got this spring here, and in that design, I needed this spring to be here when the thing is open and here when the thing is closed. So if we try to eliminate like a whole 2 millimeters from this minimum distance, then that's like 2/5 gone. And so 2/5 gone also from this maximum trap from this distance. So 17, 2/5 of 17 is like 6.5 millimeters or something. So now the maximum distance is like here. And the maximum travel, which was 12, is now like 4 point something. No, 8 point something, like 8 millimeters or something like that. And we needed 11. So it doesn't work either. We just need to find space for this spring to sit in its minimum configuration and its maximum configuration. That's what we need to do. There's got to be a way to do that. Let's look. Okay. So we know that there's going to need to be a rectangle of 5 millimeters by 6 millimeters, essentially. Let's go for the 6 millimeters. 5.5 by 6. Let's just say 5.5 by 6. As soon as this stops buffering, I'll be sure to draw that rectangle. Okay, here we go. I'm going to draw a 3-point rectangle here, and we're going to call this, it's going to be 5.5 tall and 6, don't, 6 wide. Then, dude, like, what if we went here? You know? What if we kind of eat into both of these parts a little bit with this spring? That's certainly possible, right? There's no reason why this has to have all this material over here, right? Where's our PCB? Yeah, it's not about moving it farther away so there's the most space for it, then we don't get the travel. We can do less than the maximum travel. So let me see. If I make this coincident there, and then also make it horizontal, so here we get. So we get something like this. And then, yeah, I say, why not, right? Then we can have this spring. So if we take this and rotate it 67 degrees. No. Hmm. Okay, but it doesn't. Uh, okay. Let me just see here. I need to do a pattern. So this is something I can move around. Center point here. 2 partial at an angle 67 degrees. This kind of sucks. I agree. This probably also wouldn't really work. But could I just like, I don't really need this, do I? The spring can exert forces in like all kinds of directions. It doesn't have to be like an actual force around this arc, but then things would have to rotate and maybe would not be good. The colors, they're all flat. Let's see. Okay, chill, bro. No. I am pink because my camera is weird. But watch this. Watch this. I can be anything you like. I can be yellow, I could be purple, whatever. Let's be I'm cyan. I'm cyan. I'm cyan. I'm cyan. I am cyan. Okay. This is what I'm looking for here. Is this kind of Okay, so this is possible. Right here. This is the configuration that I'm looking for. That's it. That's it right there. Yes, yes, yes. I can see it now. Go think 3D. Always, always. I always think think 3D. Okay. Because I love how I draw one thing and Fusion is like, hmm, hmm, hmm. He drew a circle. What could that mean? It's like an English teacher. Don't tell me this is over constrained. Oh, it is kind of over constrained. That's okay. So this right here is the place where the spring will fit. That's it. That's it. That actually isn't why. But I don't need to explain it. I just need to deal with it. People with other operating systems have all kinds of trouble with Fusion. I've used Fusion on Linux. I've used Fusion on Windows. It can be troublesome. Many CAD software do the same thing. SolidWorks crashes. There's always crashing. Yeah, this is the real kicker is that I have too many features. It's true. So look at this history here. What I really need to do is export this as a step file, and then like start from a set geometry point. But I don't do that because I'm a little bit lazy, and I'm so close. There's no need to do that right now. So if this is the space for the spring, this is it. I'm gonna. We need a little bit. We need a little bit of space here, just for for the spring to kind of seat itself in the other part. Okay, boom. Oh shit. No, what? Add a new part in the assembly and remake based on an existing features? I don't know, bro. I don't think so. I don't think that does not sound easier. I'm not a big fan of the timeline, first of all. It doesn't really serve me that much. I feel like going back like a few moves and here and there is really good, but it's to each his own. Like it just doesn't make things more efficient for me. I'm not trying to judge anyone else's approach here. I'm just telling you what I found works. I'm very experienced, I promise you. Uh, 6, I'm pretty sure. It's better than a step? Not in my opinion. I'm not the only one who does that too. Don't act like that's a crazy thing. So really the only place I want that curve, this doesn't need to interact, is in the back. Mm, 3 millimeters. That's it. Okay. So I'm going to cut now, and then I'm going to need to build a little bit on everything else. Rick is an expert. That's cool. Thanks, Rick. Best, us rice losers have a cleaner timeline. Like best, what does the word best slash right mean in this context though? You know, like this, like, what are we talking about here? The fact of the matter is, like, if I was working with other people and this is something that they cared about, yeah, absolutely. I wouldn't fuck up their files, you know? But I'm building these things on my own the way that I feel is the best. Like, it's okay, Rick. You can be an expert. I believe it. Yeah, I mean, right now I typically go to components after like constructing the whole thing. Um, but yeah, just way too many features for sure. Yeah. Thanks, Slim Knight. I appreciate it. Really, trying to help. It's good. It's good. What's got? What's up, AZ 3D printing? How is it going? Did you step away and come back for a little bit? I remember you were here earlier. I've been here the whole time. Okay, we got to keep the tools here. I know I've been struggling with this spring for a long time, but we're finally getting there. Yeah, if it works, it's right. I agree. C-Dub 1738, the goat. He came back. So right now, I'm still trying to get this spring to fit in, and I finally figured out how. At least I hope. No roadblocks. Um, like it goes in there. So I need to make a couple surfaces, you know, extra little tabs and whatnot. But then I think we got it. Components keeps features light in the end assembly. Tried Onshape at all? I have tried Onshape, yeah. It's not as easy to use, in my opinion. My opinion. My opinion. I promise. It's okay if you use Onshape. It's okay. Okay, so I know that this is going to have to be seated down here. I want to make a quick and easy 5.8 millimeter hole. And also yep. Needs to be banished to Tinkercad for these crimes. Yes, sir. I love crime. Just kidding. I'm missing here. Did I accidentally join these bodies together? I did. Of course I did. I'm not surprised. Okay, that should be new body. What am I doing? X this out, and then need to combine this and that, and this and that. Plus, I enjoy pushing its limits. I appreciate that sentiment, Shira. That's like, yeah, if you have something that's considered like shitty, we just talked about that with my CNC machine. It's like, yeah, but like you use it and you know how to use it, you know how to push it to the farthest places it can go. That's that's pretty baller. I agree with that sentiment for sure. I think this surface can straight up just get lost. Excuse me, I thought that was going to work. Hmm. Interesting. Is this? Nah, it's not bad. Extrusion is fine in this case. Whatever. That's not tangent, but it's okay. Um. Oh, also here as well. Delete face feature. Yeah, I mean, it doesn't always work. Oh, maybe you're talking about Tinkercad. Yeah. I mean, you can delete faces in a lot of CAD software, but flip-flop welders. I welded once in my life, and I was not very good at it. My new resin 3D printer. You'll find out soon enough. I mean, there's no reason to really keep it a secret. It's just that the video will come out soon. And I'm just excited to show you guys. So the thing that I'm seeing here, I think we need a little I'm getting a little bit wigged out by my own designs. It's okay. We'll find a way through. We'll find a way through. I think that this is the right place for the spring because we've tried 2 other places, and yeah, this has got to be good. So these 2 are interfering here, so I'm gonna just take a little bit extra. You know what? No. I'm just gonna cut it. Well, I'm not gonna cut it. I'm gonna do, you know, something. That's probably good enough. I mean, come on. Of course it's good enough. Doesn't need to stick out that far. The real question is, like, should I bridge this, like, sort of gap there? And I think the answer is yes. I'm pretty sure the answer is yes. But not yet. Not yet. I'm not doing that. I'm not going to seat. Details last. You need to remember, details last. Big picture first, which means we have this surface for the spring. We just need this surface for the spring that's attached to that surface. Okay, I'm gonna make a sketch. And I'd actually like to, if I can, I think I should be able to. No, gotta finish the sketch first. Update this section view just so I can see a little bit better. Dude, you're kidding me. No! Wait, you're serious. Yeah. Okay. Fuck. Okay, hold on a second. I've got to switch these plates around. That's what I've got to do. The spring can still go there. Oh, God. Look. Thank you, Rick. Jesus. No, you're kidding me. You're so right. I'm actually dumb as hell. Oh, God. Okay, I just have to switch the plates around. The spring can still go there. Right? It's just about mm, no. No. Okay. Scratch it. You're good, Rick. You're good, Rick. This is on me. This is not on you or anybody. This is on me doing wishful thinking and. Okay. Stop it. Why am I like this? Oh my god. Okay, let's go backwards. Let's go backwards. We gotta go backwards again. Okay, so this is why. Thank you, Slim Knight. This is a reason why the timeline is important when we make dumbass mistakes like this and get to go backwards. Holy cow. You were so good. You were like, why is he making it close? I'm so sorry. There's nothing to do but laugh, really. I mean, come on. How can you screw that up so royally? It's supposed to be pulling it or pushing it open. Yeah. Okay, we might actually. Okay. Bear with me here. Bear with me. Imagine this. Imagine this. Where do we go back to? Here, right? Yeah. Okay, imagine this, guys. Imagine this. I'm just going to delete these features after the history marker because I don't care about them. This is where we were, where we thought the spring was going to go. I'm going to do what's called a pro gamer move. And we're going to see if it is indeed pro gamer. Oh, fuck. That doesn't work at all. You see what I'm trying to do, though, right? Okay, that's an option. Could we also, because it just needs to be on the, like a compression on the opposite side of the, can't you fit the torsion spring around the axle and just have, well, yes, but I'm not using torsion springs. So, like, this is really what I'm looking for, right? Oh, God. It's just not enough room. Oh, man, I know what everyone's going to say. Get a torsion spring, get a torsion spring, get a torsion spring. What an attempt, though. Buy springs that start in both loading cases. I'm really trying to keep these springs. Look, you're gonna call me dumb, okay? But I'm really trying to keep it to be this specific spring because I'm already using them in a bunch of other things in this same design. There's a method to the madness. I'm sorry that I'm not looking for what commercial off-the-shelf parts are available. I'm sorry. But this is just what I'm doing right now. If I find absolutely that it's impossible, then I'm going to capitulate. But there's got to be a way still, you know. So we're pushing it open, right? We're trying to push it open. Do I have smaller springs? I mean, these are the smallest one in the kit. The other ones I have are too small. They're like pen springs. They're not stiff enough. Can you see why I wanted to use the little tiny tension springs? Let me consider the options. Just let me consider the options. I'm gonna set the constraints here. Just let me consider the options, and then we'll deal with, if the constraints need to be moved. Yeah. No, this is a compression spring. So compression springs are nice because they seat themselves, right? Tension spring, the one I was working on earlier before you got here, is this little tiny guy here. So fits a lot, right? But then it's also these little dowel pins that I have to have holes for, and needs to have some really small features. Whereas here, if I can make this fit, I just have some nice big circular seats for either end. And trust me, it's much easier to assemble. It's another thing too, is the assembly of it. Always thinking about that. So it's this can't really fit under here, you know. So did I and it's this dang screw up here too. Maybe. I think this is easier than I think it is. I think I have a way. Just let it buffer. Should we do the step? Should we do the step now? Uh, no. It's not time. It's not time. I want to finish this base design first. Okay. Let's just take a look. So the real thing, if we want this to stay open, like we want to have this like a some kind of platform here attached here that's pushing down from here, right? So it's just like uh, okay, I'll start over. Okay. So get rid of this. I cannot believe how many times I've tried to do this. These be equal. The angle between them is. Oh, good point. Yeah. Thanks, Rick. Yeah, I haven't done that in a second. Yeah. If I do another fuck up, a fourth fuck up. How many? This is embarrassing. This is ridiculous. Okay. Okay, I'm making this so much more difficult, I think, than it has to be. Like, so much more. Or am I? Uh, negative. Yeah, you can save while editing the sketch. It is that it didn't used to be the case. but you can now. I don't know. The first time I noticed it, I think was like a year ago. Who knows? It did save, right? I can save it now. Greasy fucking fingers on this damn screen, I swear to God. Yeah, it's definitely saving. I have the stream here on a delay. Oh, maybe. I don't get to see it. Hold on. Is it saving? It's doing a thing that makes it seem like it's saving. Except it's buffering a lot. Yeah, it's saved. Okay, it's saved. Okay. Okay, where am I at here? I'm a ridiculous person. Okay, look. Look. Is this is this is this insane? Yes, but just crazy enough to work. What's the hourly rate on this spring when a pack of tortillas is $8 on Amazon? It's not about the money. It's about principle. I don't know. Just let me work on it, okay? You might be right. You might be right. Okay? Just let me think about this. Let me think about this. It's okay to waste time and money sometimes. You know, it's okay. Not everything has to be hyper optimized. Thanks, Slim Knight. Appreciate it. Thank you. Thank you for your understanding. In all seriousness, this could work. This could work, right? Pushing that way. Could work. This one is moving this. Gonna move this face. Well, one of the things I started doing like only in the last couple of years or so is rotating faces because it's kind of OP, except right now it doesn't really seem like it wants to work. Maybe I should have done that in the original shape. That's only 0.3 millimeters though. Kind of ass. I still have to remember which part goes where. No, 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 no. Okay, look, this doesn't work either. This doesn't work. This doesn't work either. Um, no, this will be assembled basically. Okay, well, I don't think I'm gonna do it now. To be honest, but the assembly is not the issue. Trust me, it would have been easy to get in there. Trust me, I had that figured out before. Um, that's not the issue here. The issue here is that this, whatever's pushing on the spring is going to rotate and end up like down here, which is not, in this profile that I have set. I think that I have screwed up. I don't think this is going to work. I don't think so. I just don't think it can fit, but it feels like it should, but I know that it can't. No, wait, wait, wait. What am I talking about? Wait, 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 I'm dumb. Wait, it is going to work. Yo, okay, hold on. Jesus Christ. Stop. Oh my God. Am I stupid? I'm stupid. I'm stupid. The spring is never gonna. I'm stupid. Yeah, why do I need to? No, it doesn't need to extend that far. It doesn't need. It doesn't need. It doesn't need. I can get this to work. I think. I'm pretty sure. I'm pretty sure I just had a panic moment for a second. And no, the assembly is not the problem. Yeah. Good lord. Good lord, indeed. Okay. Recall. Recall. You know what? I'm not going to worry about that little surface for now. I'm going to keep this, keep the shape, the profile we made. No, no, here's the problem. Here's the problem is that is that is that we should have, this is why I screwed this up. This is why I got confused because I cut. But what I should have done is just made a new body to see where the spring would be and then remember my brain can't work that this is going to be the shape of the spring when it's fully extended, meaning when this body is rotated 67 degrees that way. Okay. Okay. First step. First step. No breaks, no breaks. There's no time. I'm okay, I promise. All right? I'm okay. Right. Yeah. So I'm going to cut now, I think. Okay, so we need a couple things here. Number one, wait, before I did that fillet, I do want to make this a tiny bit nicer, if I can, if 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 the universe will allow. First things first. There. We're gonna rotate that back to 67 degrees. Well, I'm gonna model it in this configuration first, and I do apologize if I do some of that incorrectly, but I'm gonna at least start. Think, think, think. Yeah, that's pretty much the distance that I need. Dude. Are we for realiously right now? One, two, three. Okay, can't do three. 2.5. Okay, 2.3, 2.2, 2.1. Okay, 2. Sure, why not? I don't care. I don't care what the fillet is. Are all these extrudes actually good? Haven't seen without the cross section. What do you mean? What do you mean good? Without the cross section, this is what we're dealing with. I'll just show you real quick. So all of the work pretty much is in this section here right now because we're focusing on the adjustable bracelet design first, and then I've already accounted for all the other hardware that needs to fit into it. So it should be easy peasy. But yeah, the fillet incrementing is so real. So did I really? Hmm. Only extruding part of the channel. Starting at the this is the far wall, or don't know exactly what you mean. So I'll show you real quick because you were asking about the assembly. So all this stuff here, different assembly. Don't worry about that right now. So how this will look is the spring can pop into, so these are two different parts. Spring can pop in to, spring can pop into this channel like this, easy money, and then this can be placed in and then put the screw through. That's the gist of it. Okay. I need to see what's going on here. So a couple things. First of all, I'm getting rid of this. Boom, you're gone. Not that one. This one. And the reason for that is this needs to go there. The reason is that needs to go there. And I'm kind of missing my okay, I think we got to do it from this one here. I'm gonna do an intersect of this shape and that shape, and since I can't see the other one, I'm just gonna get that from here. Boom. Okay, from there, boom. Okay, then it's gonna sit in here. So gonna need to offset that. Should I or should I not? I think that I'll do the offset on the faces after this instead of on this sketch, I think. Why is we're a mile from the origin too? It's because there's a lot of other things in this file that I'm building from, and I just kept them in, but they should be gone as soon as I know that everything works. Ignorance is bliss. Yeah, I'm sorry you have so many problems with the way that I'm doing this. I mean, if you've seen my videos, like 50-50 chance it works well, right? So, you know. It honestly killed me at why is Burrow a mile from the origin too. That was pretty good. It's pretty funny. Okay, get rid of this. I do want to combine these now. The spring is going to go in this cavity, yes. And don't tell me it won't work. Okay, there's already like, or there should be, rather. Is there not? Hold on. What are we doing here? I thought that I've accounted for clearances. So there's clearance there. Huh? Yo, what? Wait. Thought this was ages ago. Let me just checking something here. What's that? I'm missing something. What is? Oh, I should have gotten rid of those. Those are just tool bodies. Okay. Oh, and of course I said show all bodies. I didn't really mean that. Sorry. Yeah, okay. So it looks like I forgot to implement some clear. Yo, the chat is rebelling. I can't. I can't. Okay. This clearance is there, but not here. Really? Hmm. Hmm. Honestly, I don't know. Is it because oh, of course. It's because this wasn't even originally touching. Duh. Okay, I understand. Sorry. It's just because I made that face just now. That confused the hell out of me. Okay. I'm sorry, guys. This requires a lot of brain power on my part. All right. It's gonna work. I promise. It's I'm on east, so it's 6:20. 6:26. I can't believe it's 6:26. That's actually insane. I gotta check. I'm gonna look at my 3D printer real quick. Okay, hour or an hour less. Okay, this spring is like way overdue, and we haven't even done the one for the linear one, which I thought was gonna be harder. Maybe it'll actually be easier if I'm crazy. Oh damn. Yeah, you did donate in euros earlier, so that was, you know. Is it Sunday already there? What country are you in, Rick? I'm just curious. I was just in Europe, so. Hmm. I've got to see this thing work. I'm so sorry. I'm keeping you up. All right, that gives me motivation, like you wouldn't believe. Um, does it make more sense to have this go all the way here? I think yes. I think yes. It just means that we got to eat into the other part. You can see what the other part is. You're North Brabant. Huh. Um, Mijn opa woont in Hedel, dicht bij Den Bosch. Uh, ik weet niet welke stad. Ja, welke stad in Noord-Brabant. Okay, gotta go over here. Ik spreek een beetje Nederlands, ja. Mijn vader was geboren in Nederland, ja. What do you mean here? You speak good English. I get you at least you type good English. That's good. I mean, everyone in the Netherlands speaks great English. Everyone. That's so funny. Um, mm, right. Okay. I need that section view back. Missing something, or am I? What's funny is my Opa doesn't speak like English at all. He's like 96 now though. And I feel like it's probably like less common in the older generation, I'm sure. But my grandma was in my Oma was an English teacher in the Netherlands, so she spoke pretty good English. I feel like his my grandpa's English was probably um uh oh um yeah my grandpa's English probably was maybe he spoke a little bit when he was younger, but not anymore. Um, um, in well, he lived in a few different cities, but he was born in Hedel, which is near Den Bosch. I was just there, and the bike ride is like what is it? It's like 30 minutes, something like that. Um, but he lived in Utrecht for a time as well, and Zaltbommel. Okay, I'm getting distracted. Are you gonna put a peg for the spring to push into both ends, or even one end? I don't know. I don't think I need a peg. I don't think I need a peg. Sorry, I'm just trying to figure this out here because this is now interfering. But does it have to? Okay, I'm gonna make this simple. Make this simple. Make this simple. Get the door. I'm really sorry about all this. Oh, why am I apologizing? This is my stream. Come on, y'all. Mm-hmm. I'm just gonna cut this body with that body. Keep the tools. So sometimes I do that. I cut and just to see the damage, to kind of get an idea of where I need to remove material. Mm-hmm. Okay, this is not like that big of a deal. This is totally fine. So why do you have this exact same compartment? I don't know what you mean by compartment. think it's gonna be okay. Sorry, I'm just filling in some stuff here. Please have patience for where the spring goes. You mean that it's like similar to before when I screwed it up? Is that what you mean? Okay, so the reason is this time that cylindrical, right? Because this is like like a revolved circle profile. The cylindrical part, which is where the maximum compressed spring is going to sit, is now sitting still in the same part, but it's above the hole, pushing down on this side. So it's going to push down here, which will put it in the opening configuration. So it is the opposite of what I had before. Yeah, that's interesting, huh? Don't mind me. I just need a little bit of a of a of shape here, and this just to keep the running fit going. Okay. As a matter of fact, it really should be another 0.1. Okay, now we do need like a little bit of a seat for this spring. You know? Where's the midpoint? Oh, I don't get the midpoint. Here, I can get this midpoint. .6 is the diameter of the spring. Give it 5.7. I don't have to make a cut. If you mean it's good how it is, like maybe, maybe not. You know? You can extrude a disc. Oh, yeah, you're not wrong. Yeah, I kind of like that better. You're not wrong. All right, inner diameter of the springtime. Thank you, Rick the Dutchman, for Rick van Brabant. 4.3 to be safe. And you're right that this is kind of better. This is kind of better. I appreciate that. because then we don't have to deal with thin wall thicknesses at all, which is quite nice. Okay. I think 1.6, and I'm going to give it a little taper of -10, -20 degrees. Okay. Okay, we might be getting to the point where in a couple operations, I'm going to be like, wow, I think we're done, you know? And one of them is here. Okay, 4.3. Do the same thing, 1.6, 20 degrees. Okay. So we're kind of done-ish. I think the last thing that I want to do is kind of finish up this surface a little bit. But other than that, pretty good spot. I think, tentatively, we will have done it. Okay, I'm just gonna like get the circle, get to there, and I think I'm gonna like make a slot actually. Yeah. Now I'm just gonna make sure. I don't think I've cooked myself with where the piece. Well, I'll find out later, I guess. I don't think I've cooked myself with where the PCB is. I'm pretty sure that I haven't. And let's go back to the section view because I got to see the other part to make sure I'm not doing anything stupid. I'm kind of doing something stupid, but we'll fix it in a second. I just want to like make this like nice. So we can go here. Just bear with me, bear with me. Let me tell you something. Let me tell you something. I'm gonna make a new body. I'm gonna split that body here. Okay, then push this face here. And then combine. Okay, okay. Have we done it? Is this everything? Let's find out. So first of all, let's take the section view and see if there's any crazy weird things happening. That looks good to me. There's not even that many like super thin walls that will cause any like issues, I think. Okay. I think I can fillet some of the walls on the moving part to make sure that, just like have as much material there as possible so we don't, inadvertently cause a, we just have this spring in a nice, we don't need squares because the spring is a cylinder. Okay. So what I'm thinking, because the spring's gonna go here, so we can pretty easily just like, no, no. Actually plugged in 23. I should have put 3 or 2. And Fusion 360 as a result is going to think for a little bit about how to make a 23 millimeter fillet in this case, even though it was just a typo. And it's really hard. It's going to think really hard about it. And then it's going to say it can't do it, which is fine. But I didn't want it to do it in the first place. So, you know. Cool. So how's everybody doing? We're nearly done on the verge of being done, and then we got this. So you know, fun stuff. Fun stuff. Hmm. This is a long buffering. I sure hope it doesn't crash. See how my print is doing. 33 minutes left. Okay, give me a hot sec. Hey, we got there. Nice. Great. Yes, I love I love personifying Fusion 360 because it justifies my anger. Oh my god. 3 millimeters is hard. Okay, it's okay. Everything's gonna be fine. Yes. There we go. Yes. Okay. That's more like it. Thank you. Just got to think a little bit more while I hit enter. Even though it's clear, it already calculated it. You know what I mean? Okay, we're getting there. So that's the spring, which is kind of awesome that that's the spring. Like, that's it. We just now have to make sure that as this closes, there's no interferences. That's the last thing. That's the last thing we have to do. Because indeed, if we look at these two parts here, hit the section view. Yeah, all good for me. And then I think the best place to see this will probably be, I don't know, maybe here. Let's just see what happens. It happens as we shut this. Okay, there's a little piece of crap there, which, okay, let me set this at 10 degrees because that's not a huge deal, you know. I don't care, you know. I'm just gonna like cut this shape out, I think. You know, I don't want to cut the little seat that I've made though. So we're gonna do that. Should be fine. In actuality, I'd rather do a body so that I can see more of it. Get these. Hey man, come on now. Cut that. Keep tools. Chamfer it. I'll do it this way instead. You're probably right, but I'll do it this way. Keep tools. Okay. Because I want to take this now, flip it so that I can see this side. Get this body, move it. Excuse me. Where is it? Here. Move it. Mm-hmm. Just give me a second. Okay. Then get these out here. Cut to there. Yep. Cut them all. Remove that. Okay. Sorry, just cleaning some things up. Is that a meme? This is yeah. This is chat. This is sorry. This is Fusion 360 right now. This is what Fusion 360 does to me on the regular. Didn't really make a crappy face like that. Okay. The last thing we're missing. Okay, call me crazy. Which, oh, that's not good. Give me 1 second. I'm gonna go like this. Then I'm gonna go like this. Can't see shit. Okay, I think that's probably good. Very last thing. Oh, never mind. It's all good. Okay, so that's the kind of shape we got. Great. And let's see everything. What are these things here? These are things we can get rid of. I'm looking to see this and that and that and this and that. Oh yeah. Oh yeah. Okay. I think we've done it. Minus 57 because we already did. Yeah. That's it. That's it, right? Because if I measure between here and here, we should have 4 degrees. Yep. Got it right. I think that's it. Which is crazy because it really looks like this is going to crash into here. But it won't. It won't do it. Which is kind of cool. Yeah. Minus 67. That's it. Oh my gosh, we did it. That's pushing it open. That's so dumb. I can't believe that. That took us so long to get that right. And this way, the spring isn't super visible. Like, it'll still be visible, but you'll have to like look through here, and you won't have to see like a tension spring stretching across here. I think it's gonna look much nicer. Well, let's see what the whole thing looks like. Yeah, it's not bad. But what the fuck is this? Don't worry about that. Don't worry about that. We're just gonna get rid of it. Just gonna back it up. No one needs to know that was there. Okay, so that's how it is, huh? That's how it is. Okay, great. Let's try this again. Just gonna back. Okay, we can't do that. Just gonna back it up. Don't mind me. I don't know why that's there. I don't know how that got there. Don't worry about it. Okay, don't do this to me. Is this gonna be some? Yes. Okay. Okay. That's it. That's the whole shebang. That's spring. Okay. Okay, Rick, you can go to bed if you want. You probably should. But I still have one more spring to do, and that's on the linear linear translation part. Yeah. And that's going to be tricky because the travel we get here, 12 travel, 12 millimeter travel, is not going to be enough because we need 15. I do have a longer spring. Maybe I'll use this one that's twice as long. The thing is, it's kind of unstable, you know? There are also bigger springs here as well. So if I have space for them, then I should use them, because so I don't have like a some kind of like gearing mechanism for no reason. You know, that's overcomplicated just for the sake of using. There's a difference between overcomplicated geometry and an overcomplicated assembly / mechanism. So here we're going from 7 millimeters. Jesus Christ. From 7 millimeters to 32 millimeters, so 25. Yeah, it's more than enough. So if we have space to go from 7 to, because we'd need 15, it's kind of a lot. 7 to, what's 7 plus 15? 22. I wonder if I should put that spring like over here. You know, maybe not. Maybe I still want the wires to go through there. Maybe it's better if all the springs are in one place. But first, do we even have 22 millimeters to play with? Not even close. So the maximum like space that we can get like feasibly, if we say this is to be one spring. Okay. Yeah, we need a little bit. Something in between. But this one. Okay, so this is 19. So we can get to 4. We can get to 4. 3.5 to 18. It's not good enough. This is a little too short. I don't even know. Could make like a 2-stage spring. This is overcomplicated. I mean, really, the problem I'm running into here is I'm compressing them for the first time, and the first distance they return to is different. Okay. What about one of these tension springs? That's easier to mount. Hmm. I need some water. I can't believe I've been doing this all day. So we're dealing with. How is this weird? How is this possible? I guess it's possible. When you think about it, this shouldn't be that hard, but it's just this spring geometry. Unless I'm doing some calculations wrong. I'm trying to think here. Because I need a spring length, like a maximum spring length, that's greater than 15 millimeters. So it's always exerting an upward force. But the cavity can be 15. But if the cavity's 15, yeah. If the cavity is 15, then it doesn't really work. Because then when the cavity collapses by 15, it's 0. So then the cavity has to be greater than 15. But then the spring has to be even longer, which means the minimum distance is longer. I don't know if a compression spring is going to be able to fit here. And what about tension springs? Tension spring could work, right? I have a little one here that I've used. Again, not like the super small one. This one's much easier to work with. Yeah, and then this minimum distance is 20.5. Wait, that's already too long. Isn't it? Is that already too long? Yeah, if I draw, which is good, that somehow this thing is smaller than this spring. If I draw an overall slot, yeah, it's too big. The biggest spring I have is too big. Sorry, the smallest spring I have, besides the little teeny tiny one, is too big. And the small one's like too small. Huh. How about that? How about that? Okay, I think we need a little mechanism. I'm not gonna look. I think we need a little mechanism. I'm not gonna lie. All right, so what of it? What's wrong with a little mechanism? You know? There's nothing wrong with that. I got like 3 millimeters to work with. What do we need? We need to... This part needs to go up. Which means it needs to push down on this part. And 15 millimeters at that. It's quite a lot of push down. It is a lot of push down. If we have a lever with a circle, we know that we're going to need secant of this circle that is parallel to this line. Mm-hmm. Mm-hmm. And that this secant, oh, for fuck's sake, has to be 15, right? Yeah. So there's some, hello? Dude. I want this to be sort of on that path. Construction. Tangent. Then can move this. Interesting. We might be able to get away with something here. I wonder. If we're looking at make this not construction slot going from here. We really don't need anything more than 2 millimeters. Yeah. Although, hmm. I can't believe we're on the last step. I can't believe this is taking so many hours. Nope. No, no, no. What's nice about making something that's so tight is that, like, everything is about fitting it in. There's nothing, no decisions are being made in regard to, like, what the best type of thing is. Oh. Okay, let me strike this. Reverse this. Don't do that. What just happened? What is that? There we go. Get rid of that. Whoa. Yeah, that's a good point, actually. Oh, boy. Mm. Thing is, there's so many constraints. Oh my gosh. The bigger this is, the better. Let's think. Two millimeters. 2 millimeters. 2 millimeters. Then let's say these are tangent. Basically meaning that's the maximum we can get. And then I also need this. Oh no, I did the wrong slot. Although, yeah, we kind of do need a weird shape. Okay, fine. We'll do this. This one is 2 millimeters in diameter. Then we can do an arc, slot arc. Here, here, 2. And this goes tangent. It is interesting. That's 15. And then this is actually not terrible. I'm gonna need to, I don't know. I'm gonna go here. This should be not too crazy of an angle, I think. Okay, I know what. I think that this right here, that's got to be facing down. So it's 1 millimeter this way. Oof. Very much not facing down. Wait, but that has nothing to do with the arc at all. Huh? No, no, no. Okay. Line here. Okay. That's got it. That's the max. That's certainly the max. Okay. this one and this one are equal. And then this one, what happens vertical? Ooh, wow. Yeah, but it makes sense that this would have to be like super duper curved. I'm gonna get rid of this tangent constraint here. Yeah. This is not crazy. Hmm. We've just got to get it out of the way here, I think, if possible. Yeah, I mean, just why not? Why not that? Why not that? I think it's totally gonna work. Just from here to here, right? Mm-hmm. Yeah, we're gonna run into the same problem of rotation. Great. What's up, Marcelo Ramirez? What's going on? Welcome, welcome, welcome. W live stream, bro. I'm losing it. I'm losing it. It's been so long. What does it say? How long has it been? I go back to the beginning. What is it? What is it? What is it? 2 hours, 3 hours, 4 hours, 5 hours, almost 6 hours. Whew. I feel like it's been longer, no? Maybe I'm crazy. But we're so close. We're so close. We're just trying to tackle one last problem. That is the try to fit a little tiny spring. Well, in short, we can't just we're trying to get these two, these two parts here. They're going to slide past each other. The problem is that when the spring, like if we want a spring to fit in there, because they need a resting position. If we want a spring to fit in there, the most compressed it's going to be. If we want that to fit, it's not going to. Wait, am I not? Am I dumb? Am I dumb? Yeah, the most compressed it's going to be is too small. It's not going to fit. It's just, yeah, it's not going to fit. So, yeah, I'm trying to make a little tiny mechanism to basically gear this down. Mm, okay. Mm-hmm. Oh, we got the crash. Okay. Let's reopen it. Finally. I'm actually surprised it didn't happen earlier. Yeah. Okay. Come on. Come on. Gosh. Time for more water. Gotta stay hydrated. Try recovering. Okay. It says it saved 6 minutes ago, so it should be fine, right? Okay. Let's get this done. Come on. Come on, come on. You know what, though? No, alternatively. Wait a minute. I don't know if this is gonna work. Actually, it has to. I'm still feeling this one out. That's the truth. Yeah, that's what I thought. Whew. Okay. I think there's a better way. There's a better way. There's a better way. Hey, there's a better way. That crash, best thing that happened to me. Because there's a better way. My dumb. Sup, bro? AZ3D, welcome. We're again focusing on trying to get the linear version to have a spring now. Dude, I know. I'm so upset. We're almost done though. This is the last feature. The spring. So I'm thinking about a lot of things. I'm thinking about that we've got a 20.5 millimeter spring at rest, and it can stretch pretty far, so we don't need to worry about that. Ouch. But okay. Let's just see. And you know what? We're just doing some one thing. Okay. go here. Making a sketch. Wait. 1 second. 1 second. Here and here. And this pivot. Up. Making a sketch. You should go up 5 millimeters. Maximum adjustment. Okay. And then, so this should be the spring at its smallest, or slightly bigger than that. We keep dropping these. Great. Okay. So what do we got? Pretty much the same thing. 6 millimeter diameter. I should have gone for the overall slot, but I think I can just do this. Okay. So imagine. I'm gonna offset this by 0.4 and say that that needs to be tangent to that. Oh, no. No. 20.5. Okay. All right. Yeah, I mean, like, I don't know. This isn't like, is this just impossible to get right? Shouldn't be. I think we are going to have a slight this is just a slight inconvenience, really. But is it that big of a... Oh, wait. Oh, wait. Actually, up there. Oh, okay, stop. What? This should be going the other way. Or that's a compression spring, but that's dumb. Okay, great. Let's do it like that. Okay, so it won't work. Motherfucker. Okay. So that won't work. I'm losing my mind. I'm losing my mind. But why must I lose my mind? Why is that fair? Dude. There's gotta be something here. Gotta be. Oh my god. I feel gross. The very last thing. Really? What's the distance here? 12. Yeah, of course it is. Gotta keep this concealed, this spring, somehow. How do we do that? Mm, how do we do that? We have to have this stupid mechanism. The farther away it is, the better. We know that, right? Okay, we have to know that. The farther away the pivot is, the less extreme the rotation is. We know this already. Let's make this 2. Whatever, 3. No, this should be 4, because we're going to need to fit a screw in there. So let's move this all the way over here. Then let's project this line, give it 3, and we know hmm. Okay. And let's say that the minimum place for this, some construction line here. Yeah, that's fine. That's fine. 2 millimeters from the bottom. Which means we now have, that's 2 millimeters. I think I know what the problem is going to be. but maybe not. This can be 2. It's going to be 2 millimeters. Meaning we'll make this Hmm? Hmm. Yeah, good point. I'm not even talking to anybody. I'm literally listening to my own voice in my own head about this whole situation, and I just go, yeah, good point. Jesus. Whew, I'm losing it. I think 16, right? Or or 15's all right, actually. Yeah, I'm literally talking to myself. Sign of madness. Okay. Because we are going to need this to be like the thing it pushes on. Okay. Great. And then if we offset that surface by 15 millimeters, we're up there. This suddenly doesn't seem like insane anymore. Okay, because we've got... Ooh, yeah. How does it fit in, though? Kind of pokes out, but not really. Doesn't really poke out at all. I just need to see where this hole is going to be with respect to the rotation. So we can draw the shape around there. Hmm. Well, it seems to me like as long as Okay. Look, I'm just gonna make this body and see what it can do. Let me also make another body here. So I'm going to have this sort of rough and tumble version of this mechanism with just an arm and a surface. From this object to this object. Not join. New bodies. Okay. Let's see. Get the section view here. Hmm. I've missed something. What have I missed? Oh, I've missed the fact that what happens? Okay. Either way, though, it's almost golden hour, but you guys can't see it because I'm blue. Da ba dee ba da 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 ba dee da ba da. Okay. Blah 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 blah. Brain machine broke. Brain please machine please come back. So it's like just barely touching. So I extend this a little bit more. If I extend this a little bit, okay, and extend this a little bit, and hold your horses. I don't need two. Well, you know what I also need to see? If oh, it does miss the hole. Okay, I think we're on track. What's up, Rakens Bay? We got to work on this thing. This lever to push this thing down. You know, that's fun. Anyway, how are you? I'm just changing the shape of these slightly. To be 1.3, 1.2. Think like there and there, and then there, and there, and there, and there. And honestly, kind of want to keep some of this circular surface, you know? So if we can do that, that means these two be parallel, and this one here. It's not bad. It's a weird coincidence, but whatever. So now we have a little lever that fits in this thing. Just a simple lever. It's pushing down. Oh, woobada, woobada, boobada, boobada. Oh, good lord. You see? Goes from there, pushes there. Okay. So now I'm going to do a little offset. 0.1. too. We need to make room for this thing to rotate. So we cut out the circle path. .36 millimeters. It's amazing. It doesn't even actually cut in that much. And I'm going to deconstructify this and this and this and this. And that, honestly. This. And good. Okay, honestly. Okay. Oh, excuse me. New day, new webcam color. It's me, the cyan boy. Okay, it should be not construction. Okay. I'm just going to draw a line from here to here. And constructify, everything in here. Inside, constructify. Just making space. Constructify. Good. Looks good, everybody. Looks good. Okay, I'll just cut this here. Making space, making space. It's just like Wicked, like the Wicked press tour. Everybody's holding space. Whoa, brother. Oh, I see. Okay. That's the cutout thing. There's a couple. This is the one. Mm-hmm. 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 Gotta keep these. Yeah, just those three. That's sitting in there. we are going to need to carve out a little bit more space. I think this will glare on my screen now. I'm just going to cut through this. What is that doing? There we go. Okay. Get rid of that. Goes there. I am working on a mechanism that will allow a lot longer force force transmission distance than a simple linear spring, because we need to, like, there's sort of a discrepancy between there's sort of can you there's sort of a discrepancy between the minimum, like the minimum most compressed length of the spring and the maximum transmission distance. So we need for instance, we need a 15 millimeter transmission distance. We need force to be transmitted in a certain direction, like if these things are 0 millimeters apart, all the way till they're 15 millimeters apart. But then the problem is, for the springs that are long enough to do that, the minimum distance, the minimum length of them when they're fully compressed, is too big to fit in the design that I have. And we don't want to make the design bigger. We want to cut down on the bulk. Sure, dude. Why not? Don't do this to me. Oh, you did it to me. I knew you would have. I knew it. Oh, okay, never mind. Why don't I just take this? There we go. thing. I don't want things poking out the bottom. So we're going to make sure there's none of that. And it's 824. You guys know what a CAD design takes for me. The crazy shit that I need to do. It doesn't help that there's buffering. So I'm essentially just going to make sure that this is good. Oh, you need a little more. Okay, I got you. 420. All right. Mm-hmm. So this thing rotates, pushes down on that to go there. We need to see something else because I know that it's not going to work like this. There. Okay. Yeah, we're just going to need to extend this all the way down to here. Mm-hmm. This will make space for everything. Then I think finally we join this device with this device, body, whatever. Okay. And then this one and this one you can get rid of. So what that means then is that when this and this and yeah, that's all I selected, I guess. That's fine. Please tell me I didn't select other stuff. Okay, good. That and that go all the way back down. Well, let's move this to minus 15. This one will have rotated to here. Perfect. That is what we want. So, then we just need an axis and a spring, I think. An axis and a spring. An axis and a spring. So the spring doesn't need to flex as much. But first, let's take a look. Let's take a look. All the way back over here. Okay, and then I think I'm just gonna, I don't know, is this crazy? Just extrude that so it's easier to assemble. I know this kind of intrudes on our spring compartment over here, but frankly, I don't think it'll be a problem, and I don't care that much. I think it's kind of cool that they are so close. I do, however, think that I can add some walls back. Just for the sake of it, which I think will be worth it. Just like that. These parts are becoming quite complicated, but that's okay. They're not insane yet. Whew. Then we just need something pulling this down or pushing this down or something like that. There might be room for some pushing. The same spring that I've been using this whole time that I've been so intent on may be back in the running. But first things first, we need the axle. So I can get away with 9 millimeters. So I can use an 8 millimeter screw. Good. And we're going to shrink this to 1.88. Sorry, we're going to shrink this to 0.1, 2, 1. I'm pretty sure that's it. Let's go. Okay. Then we need the chamfer. Well, let's see. We may not need that. We may not use it. We may need to extend this somewhat, which is interesting. Which is certainly interesting. Jeez. The print is surely done. Oh, yeah, I've already seen the print is done. Uh-oh. Yeah, of course it's done. Okay, so we're not going to do the chamfer yet. What we are going to do is think about the spring. I'm going to take a look at this. Because we know we can get away with 5 millimeters. Three-point rectangle. 6. Whoa. By 5. Okay, that's a big spring. Okay, and so let's say we definitely need nature calls. Be right back. Feel it. I can taste sweet, sweet victory. And honestly, this might be easier than I think. But maybe not. Maybe it isn't. So we kind of need this to, well, so 12. Yeah, we're well in the range of this compression. I think the farther up we move it, the happier we're going to be. So that's really the best that we can do. What if we put this next to this tangentially? So if that's tangent, then I'm going to rotate it, and we're going to need it to like sink in a little bit, and then, but I think it's going to work out. I'm such a fool. Well, I think it's going to be worth it. Spent a long time on this, but for good reason. Ooh, look at that. Look how far up we can make it. Okay. So what about this? Where is the end of this spring going to end up? Like this is, of course, that's necessary because it's going to be fully compressed. So it is going to need to have some room. No. I'm just going to wait. This and that. I know it's just going to be those two. We're going to rotate around this point, and then we're going to measure the angle between this and that. We're going to negate it. Man, what the hell? Okay, wait. I gotta think. Get rid of. Okay. Something's up. Something's up. Breathe. Okay. Let's see here. Okay. I'm gonna get rid of this constraint. And I'm gonna get rid of the tangent constraint. What I really want to do, really, is have. Wait, but I just did that. I just did that. There's some line of action. Oh, wondering. I kind of need this angle to be more close to 90, like 80. Right? So maybe this would be 550 and not just 5. Okay, so what happens if we take these and rotate measure the angle of rotation, negative. Okay. This feels more real. You know what I mean? I think this can work. It's not the way compression. It's not the, it's not the way compression springs were meant to be used, but they could be used in this way. Who cares? You know? This is tight. That's 0.2. So I'm going to go for 0.4. And okay. the spring is going to sit like here, at least in my eyes. And I'm going to make a new body to act as said spring. And we're going to fillet the edges. I think there we go. Okay. Spring, but you. It's nice that this spring is quite stable at angles like that. I think it will work. So then it's just a question of, I think, just like everything else, right? I'm gonna draw something here. What is this shape that I'm seeing here? Oh my god, it's almost 9 o'clock. That's pretty sick. I love it when it's 9 o'clock. Oh, wow. Okay. Come on now. Hurry up. Thank you. Look at that. That's not nice. That's not nice at all. Oh, wait. Well, here's a question now. Here's a question. Here's a question. I have questions. And the question I have right now is, This doesn't need to be over there. This could straight up just be like right here. This spring. Yeah. Literally right there. Man, maybe not that, maybe not quite there. A little bit less. Like there, yeah. Okay, so with that, then it's easy and simple, and you just take this and sort of, you just kind of cut there because it's not going to be a problem. Then you go here, call it 3.1, maybe just 3 to be safe. You call that a new body, okay? You fill it that because you can. Then you combine this body, that body. Then you chamfer 1. And this means that we're going to have a, from there to there, 12 millimeter hole. So I'm just going to go an extra 0.5 just for good measure because I can use a 12 millimeter screw. And then we're going to go here and we're going to cut that. And oh, I should have kept the tool. And we're going to cut this. And guess what? That's it. That's it. We've done it. That one goes there, pushes down on that, which pushes down on this body. And that's the whole frickin' thing. But I have said that before, so let's think. Spring lever. I want to get a little section view action here before I... Oh, what's this? Oh, no, wait, that's okay, right? Yeah, that's all fine. Okay. You can see it from this angle here. This moves down to here. So in this position, there is going to be tension because this body will be like this, pushing down because the spring is going to be pushing here, going to transmit that force through there, pushing that down there, and yeah, 20 degrees from there. I'm pretty good at this. Took me a while. That's the whole design. It's just a question of, do I separate the ratchet from the 3D print or do I not? I honestly think I should separate the ratchet. Just cause. So what that really means is it doesn't mean a whole lot like at this exact moment. Um we just need to look at two parts here. This one and this one. Because those are the ones that have little teeth. That's going to need SLA printing. And the dovetail being SLA printing would kind of be sick too. And probably will need to. And all this stuff over here would be good too. Do SLA printing. So it's not too difficult. Over here, I'm kind of like, yeah, this is kind of, what I thought I might have to do. This is going to fail. Yeah. Okay. Because this part has so much detail. That part has so much. Whoa. Okay. So, gonna need to add some offset here. First of all, easy. And I think 4 screws will probably be enough. going to be kind of tricky. Mm-hmm. I'm going to fall asleep, man. I've been sitting here all day. Okay. Four millimeter offset. Okay. Cut into the pressure vessel too. Let's go -6, -7 even. Okay, we can't do -7. -6.5. That's exactly what I wanted. Because we can do... We've got to fit the screws in. So we've got to make it easy. Yeah, it should be fine. Crazy details everywhere you go. Crazy details. And then we chamfer. Here, 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 here. This is how we have this two different manufacturing methods come together. Okay. Okay. Good. That's taken care of. Those are now separate. That's one part. That's another part. You'll love to see it. Okay. We got to do a similar thing over here with this ratchet, which should be... I think that's gonna be much easier. It depends, because I also want to do it over here. Dude, come on, yes. Focus, 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 focus. Oh, focus, focus. You had it. You had it right there. No, 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 no. Not that one. This one. Because I got to see where the circuit board is, so I don't fuck that up. But okay, so that's there. Oh, that's kind of bad. I'll fix that in a second. I'll fix that in a second. All that time spent on the circuit board, and I messed it up. Okay. I think this one we don't need any extra screws. We just have it be constrained by its geometry and the fact that it's going to share an axis. So it will be forced to rotate with the other part that is containing the you know, stuff. That feels right to me. That sort of shape. Get this chain minus 0.1. Oh yeah, that's the one. Okay, and then we just need to cut this body here. And cut this body here. And then we have to combine again, right? This one, that one, and that one. Oh, did I keep tools? Never keep tools. Okay. Okay, and then we hide this. We offset, and we offset just enough so that it will fit nicely. And there we have it. That's the ratchet part, the part that requires detail. The rest of this part Does not require detail. Only issue right now is that the PCB is sticking out a little bit here. Oops, 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 oops. Let me look at the part that goes there so I can check this out. I think the issue here, it's really just a this surface versus that surface. So let's just make this go up by 0.2, right? And make this go backwards by 0.2. Holy cow, what was that? Sure, dude, whatever. Why'd you... Okay. Okay. Then 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 we take this and we just see if there's any problems otherwise. And I think that there are not any problems otherwise. Great. Holy cannoli. Holy Obi-Wan Kenobi. We did it. Wow. That's it. That's it. That's it. That's everything I need to print, right? Totally to test out this bracelet and see if it's nice, adjustable, easy to use. Everything. That's the whole design. Okay. So if anyone's still watching, thank you so much for tuning in. I think the people who contributed cash are gone, but if they're not, thank you. We have something really special here, I think. And it's going to be a sleeker bracelet than the ones we had before, but it's still going to fit everything in. It's going to have more fluid storage. It's going to be a lot easier to put on and take off. That's a huge one. And I've incorporated everything that I've learned. Everything. So, yeah. Thank you guys for watching. I'm going to tune out now so that I can make this and test it. And we'll see if it works. Thank you guys so much. I'll go big for the goodbye. Thank you guys so much. And I'm sorry that I'm blue, but I appreciate it. And I'll see you guys. Stay amazing, stay safe. And I'll see you guys in the next one. I got to take a nap or something. Okay, bye.